Hey guys, is this working? It does say live, so hopefully should mean I'm actually getting stuff across. Alright, so this stuff is on number theory. As I've mentioned, I showed the video before. If you did miss the video, it's like right here. Pretty much everything is in the description. You can get like so many different things. Actually, I probably should have linked my number theory template, but whatever. If you go here to this code that I have, then you can go to templates and then number theory, and then you can find all the stuff that I have implemented. I also forgot to mention sieve. I think I will go over that briefly, but here, like, this is just the stuff I've implemented. It's not actually that much, but it's there. Hang on. You guys hear me all right? And stuff like that? It's general check of setup. Okay. Sweet. Alright, so I'm gonna go over sieve first because I forgot to mention that. And then we can do these problems. And I see that this time at least, or like everything has been solved at least once, which is nice. I don't know where my pen is, which is also nice. I literally had it like right in front of me. I don't understand. Okay. Yeah. Alright, so let's start with sieve. I'm just gonna do that. Although sieve is actually, yeah, here you can see the thumbnail. Sieve is actually really simple. So, let me just get that over with real quick. So imagine the goal of sieve is to find all primes from 1 to n. So in the range 1 to n, it will just find all the primes. And it can also factorize all the numbers between 1 to n. Or rather, it will let you factorize them. And the complexity for this is O of n times the log of n. I'm not gonna go into where that complexity comes from. It's kind of like calculus, I think, but the main idea is, here's how it works. So to do the first thing, imagine like all the numbers, imagine like n up to 9, or 10, I guess, sure. So what we're gonna do is, well, 1 isn't prime, and we'll just ignore 1. So for 2, what we do is, because we have not found any divisors of 2, meaning that 2 is prime just because like we don't know of any divisors of it. And then now that we know that 2 exists, we're going to cross out all the multiples of 2. So we're going to cross out 4, we're going to cross out 6, we're going to cross out 8, we're going to cross out 10. And the reason we're able to do this is because we know that 4 is a multiple of 2, since we just determined that 4 is a multiple of 2. And we know that all of these numbers are multiples of 2, meaning they can't be prime because they're the product of something and 2, so they're not prime. And we do the same thing for 3. We say that 3 we've not found anything bad for 3, so 3 is good. Then we cross out all the multiples of 3. So we cross out 6 again, we cross out 9. 4 is not prime, meaning that we can just ignore 4 because we already know that we've gone through 2, and anything that's a multiple of 4 is a multiple of 2 as well. So we can just completely ignore anything that we know isn't prime. Now 5, we know that is prime, so we cross out 10. 7 we know is prime, and that's it. So the numbers that aren't crossed out are the ones that are primes. And the reason this works in n log n is because, like, magic. But the way we can use this to factorize numbers is in this process that we're doing. What we can do is we can store the smallest, we can store a prime factor of each of these numbers. So for example, for 2, I'll re-illustrate the process now. For 2, we'll say 4 is divisible by 2, cross it out, and we'll say that its prime factor is 2. Because of the fact that we know that 2 is prime and we know that it's a prime factor. So for 6, same thing, we say its factor is 2, 2, and 2. And then for 3, we do the same thing. So for 6, we can replace its prime factor or not. It doesn't matter which prime factor you store. You just need any of them. And then for 5, we say 5. Right. So now for each number, we know a prime factor of it. We know some divisor of it. And the reason that's cool is now because the reason this is cool is because we can trace these prime factors back to 1. So what I mean is we know 6. And we know that 6 is divisible by 3 because we just wrote that down. So 6 is equal to 3 times 6 over 3. And then, so we know 3 is a prime factor. Now we need to factorize the rest of this, which is 2. And we know the factor of 2 is 2, so 2 equals 2. So overall, 6 is equal to 3 times 2. If we were to do this with a bigger number, say 100, then maybe we know that 100 is divisible by 5. So we can say that 100 is equal to 5 times 100 over 5, which is 20, which is equal to 5 times times 20 over 5, which is 4, and you get the idea, right? So we take these prime factors one at a time, and we just keep dividing by them until we don't have any prime factors anymore. So this is the exact same complexity as sieve because you're just doing the exact same operations. So overall, both of these things are n times log of n. Okay, I think does that make sense? I'll take some questions now. What DP problems do you recommend? That is a good question. I did do a couple streams on DP, but it's not an exhaustive list. And then, I guess you could really pick any site. I mean, Codeforces has some DP problems. I'm sure other sites do too. I don't have any particular recommendations, but many of the sites are probably just fine. Bit manipulation, it comes up a bit. Yeah. Have I done pure maths? No, I have not. Not really. Well, I did take a discrete math class, and that sort of helped me with proofs, but I got good before I took that class. CSES, I have glanced at it. Most of it is pretty, a lot of it is just copy-paste something for me, just because a lot of that knowledge I already have. The additional problems are pretty cool, though. Okay, kind of forgot to mention this. So make sure we go in and notify. That should work. Let's do some admin work right now. Alright, we should be good. Text on what subject? Math or number theory? I don't know of many texts, to be honest. I'm not the right guy to ask about that. This is a MacBook. The reasoning is because I was recommended it. That is why. Yeah, I don't know. I don't know that many resources. My brain doesn't work that way where it can associate things to like a list of other things. Does inclusion exclusion come up in problems less than 2000? I am not aware of that, but probably. I would not doubt that that was true. Alright. Anything else? Oh, is there a coach of stuff? God damn, I always conflict with something. I don't know. This was like I deduced that this was the best day to do it though, because if I did it earlier, then there would be no time to do the problems, and if I did it later, then it would conflict with other things I wanted to do in the week. So like I don't know. There's no best time to do it. Does graph and bit manipulation? I would guess it doesn't, just because there's only so many problems I can do. But I try to get a good variety and cover a bunch of different topics in it. College life. It's a life. It's a life. I'll say that. It's a life. I don't know if it's necessarily a good life, but it's a life. You're welcome for that stunning commentary. How many hours a day? Used to be like anywhere from 2 to like 10 on weekends. That's kind of a lot. Maybe like 8 or something. I don't know. It was a lot, but yeah. Now it's like a lot less because I'm kind of lazier now. I have not solved anything in this stream. I just started the first problem, so you are not late. Let me I always pin the message. Try not to drop my pen. So yeah, sure. I'm sure there's some conflicts. The stream is going to be available like every other stream. It'll be an archive. So everything should be fine. I'll pin that. Can I edit? Wait, hang on. I want to see something. Can I edit a pinned message? No. Okay. That's sad. Do advanced geometry come in ICPC? I'm guessing. I don't know that much about ICPC. Basically, my practice strategy for the last day is just to try and like do a single contest, and I haven't seen any geometry on that, but I'm sure it shows up. Does it make sense to practice greedy? Yeah. You need to get the intuition for it. Do you have any plans for making a roadmap? Probably. I think I will do some sort of long form ladder eventually and break that into multiple videos. That's gonna take a while though, because I need to... My plan is going to be to ask people who made it work. Since I sort of like skipped some of the lower colors because I came in with a bunch of experience, so I don't know what the experience is like on Coforces, so I'll have to ask around. That's why it would take a while, if it does. Long hair, it's like, I mean, it's like, you know, it gets in the way sometimes, but it's not that bad. Do I deduce time and space complexity? Yeah, I usually mind calculate it each time. You get used to it pretty quick. You get like, it's a bunch of pattern recognition, and then you see just like certain things. You associate it with taking certain time complexities, and then you can just crunch out the numbers. Wait, how do you edit the pinned message? I can like, can I unpin it, edit it, and then pin it? I want to try that now. Wait, can you even edit messages on YouTube? I don't think you can. How do you do that? How to improve on DP? Just practice it a bunch. Honestly, that's the best way. I don't have a better alternative. Practicing is just the thing. Okay, I'll take a couple more questions, and then we should get started with the problems. Although actually, the class that I was scared of the stream conflicting with got canceled, so it's like a sign that I should be streaming today. I don't know. Is it important to know advanced data structures? Definitely not on code forces. You can get through a lot of it without like for example, I don't know quote unquote basic things for reds like treeps or link cut trees and stuff like that. I will eventually learn those, but I do not know them yet. Do I perceive the problem from the optimized model? I'm not sure what that means. Like, do I think of it mathematically? If so, usually yes, especially in this stream. Where did I learn C++? I knew Java and Python, and then I basically just self-learned it by like looking up stuff like, you know, stuff like that, and then I would piece my program together bit by bit, and then eventually get used to it. I don't have coding interviews yet. Video and IDE setup. I said I was gonna do that like a few months ago, and then I have not done that yet. So I'll probably do that, hopefully do that soon. Dyeing my hair white. We'll see about that. How do I skip college classes when we have participation grades? That's kind of hard. Because every class has like, it's either participation or it's like, you have to tune in to get like, to understand the lectures and stuff. And not to do typos, type more carefully. Stuff like that. Average typing speed, it's like 100. Although you don't really need that fast of a typing speed. If you can type slowly but you can think fast, it'll balance out. So just get good and then you'll become good. Okay. All right, we'll do this problem and then I'll take more questions. Yeah, I can't, if I spend the first like 5 hours answering questions, we're never gonna get done. So I'll take questions after doing this problem, but this problem is quick. So this problem is called maximum GCD. I'm gonna do a Q&A stream later, by the way. I think that could be well received. So this problem is called maximum GCD. And the idea is, well, I'll just read the statement. Let's consider all integers in the range 1 to n inclusive. Among all the pairs of distinct integers in this range, find the maximum GCD of integers in this pair. Right. So the key word here is distinct, because if it were not distinct, then we can simply take n and n. So like if it were not distinct, we could just take the pair n and n. But like the key idea here, well, actually there are two. The GCD is less than or equal to the minimum of the two. And also, because the GCD has to be a divisor, like a divisor can't be, let's see. So if x is a divisor of y, then if x is a divisor of y and it's not equal to y, then like you can deduce that x has to be less than or equal to y over 2. And the reason is because like you cannot, like you have to divide by something and it has to be at least 2. Right? So it has to be at most, it can't be more than y over 2 because you have to divide by something at least 2. So the best we can do is around n over 2 because the divisor has to be something. And That divisor has to be, it can't be larger than n over 2. And it turns out we can get n over 2 because if n is even, we just take n and n over 2. And if n is odd, then we take n minus 1 and n minus 1 over 2. Let me just show that's the best we can do because you can't do better than half of n. And we just achieved half of n. So really that's the answer. The answer is n over 2. In fact, I'm gonna write this in Python just to be annoying. Because it's like a single, it's like literally a one-liner. All right, actually, do we have test cases? Oh yeah, we do. Okay, never mind. I'll just be normal. There we go. Read an n, print n over 2. We're done. I hope. Unless there are queue issues. Which there are. Love that. I guess it's just slow. Okay. Well, while we're waiting for that, I can take more questions now. What do I think about Rust? I have not used it myself. I do have a friend who used it. I'm not sure if he was being sarcastic or he actually likes it, but I do have a friend who uses it. I'm not exactly sure what his opinion of it is though, but I don't know of it myself. How hard is my college? It's more projects and stuff like that, which is kind of annoying because it means there's no easy work to take out first. Everything's sort of a big thing. Oh yeah, timestamps. I've perpetually forgotten to do that in the last stream. So I'll do that for this stream and then hopefully remember, I'll try and do it for the last stream too. I'm sorry about that. That was kind of a mistake. I am in my dorm right now. There's not much to see, but like here is my bed. I have the donut there. I mentioned I plan to hang it up eventually, but like I haven't done that yet. So hopefully it'll be on the wall sometime soon. Alright, make sure I haven't missed anything. Programming courses would you prefer? I don't know if you need any courses. I never used any courses. So it's not necessary to use any. So I don't have any to recommend because I don't know any. But I'm sure other people have had experiences with that and they can help you better. We're using Kotlin. I have used it before. Actually, I haven't used it. I have won shirts from Kotlin Heroes before, but I used Java and then I converted it to Kotlin. So I don't actually know Kotlin at all. Like I don't know a single word of it. So I can't comment on that. But I do know Java, and Java is kind of painful in a lot of ways. Have I used Golang? No. How can you support me? There is one thing you can do. You don't have to donate or anything like that, but if I announce a video in the community tab, watch it, because those are the ones I'm trying to get to blow up, and the ones that, if a video gets a lot of traction among subscribers, then it will get farther in the actual algorithm. So that would be the best way to support me if you want to do that. Video tutorials and training gateway? Not that I'm aware of. I think it's there might be some issues against terms of service with that. I don't think they like people sharing solutions because it sort of ruins the gig of it. So I don't know. I'm not aware of any. What country? USA. Is it fine to know only segment tree? I don't know. What do you define as advanced data structures? Like if you give me a list later, not now, or if you ask them one by one, I could probably tell you over time. Segment tree isn't like that necessary until nowadays. It's like 2000s or something like that. Don't quote me on that, but it's around that estimate. University, UMD. What type of pipe? I don't know. These pipes are just. All right. These pipes are just like here. I'll show this angle too. This is very awkward. Yeah, these pipes are just like here. I don't know what they do. I don't think anything has ever gone through them since I've been here, which is good. But yeah. Have I done ICPC? I have not done any ICPC at all, so I haven't done finals. This year is like, I've heard it's like February or something. February or March. So I have not done anything yet. Oh, Kotlin for dev? I don't know that either. I haven't used it for anything. I heard it's good though, or like versatile. Any other fields except computer science? I am getting into investing at some point. I think that is part of my life's plan, but I don't know that much about it yet. Why Java is painful? It's just long, and there are a lot of things you can't do in C++. Like, you can't do defines. There's just the annoying like typing part, or like not like typing, but like data types and stuff like that. It's just a pain. Like, you need, like, it's convention to use something like array list of whatever, right? And then you have to like do that again. And then like you do a bunch of stuff. And it's like a lot of just stuff you have to do. I don't know. I just don't like the amount of text that you get on the screen from a Java program. I mean, I'm sure you've heard the same. If you saw Second Thread's video on dumping Java, you'll see a similar sort of complaint. And he uses Java all the time, so he's qualified to complain about it. Yeah, as enterprise and stuff like that is probably pretty good. Linear what? I don't know what linear DA is. Smart observations of second tree? Yeah, maybe. But really? Like, is it that common that you can do that? Michael and Pam's office. Yeah, I kind of get that vibe actually. It's like you literally have pipes running to it. I won't be surprised if there's just sewage running through here on the daily. That's a funny thought. All right, a couple more questions and then we'll do this one. I just started coding. Any advice? I have a video on mistakes to avoid. You could start with that. Why do I use 64? Because I use longs everywhere, and that's because I'm scared of overflow and I'm too lazy to like figure out what my numbers should be, so I just make everything long. And 64-bit is faster with longs than normal. Like, it's designed to use longs instead of ints, so I think it is better for my purposes. Linear, like arrays? Arrays you should definitely know. Linked lists, like stuff like that, I don't think you need it that much. If you're talking about stuff like binary search trees are like auto-implemented. Like this right here is a balancing binary search tree already. I think it's, I don't remember what kind, red, black, or something like that. But like this is just sort of there for you. So a lot of the things you don't need to understand them because they're just done for you. Text editor, it's called TextMate. It's just sort of the first one I found. I'm sure there are better ones out there, and I'll eventually switch to something else. Do I like Fenwick trees? Yeah, but I don't understand them, so I'm kind of scared of them. I'm sure they're not that hard to understand, I just never made the effort to do it. Major CS, sometimes it causes TLE when you use long. That, are you sure it's because of long? Like sometimes it is that, and it's like a factor of 2 off or something, but usually that's like only when your program is really, really close to the time limit. And also like, I mean like, yeah, if you use 32-bit and you use integers, then it's probably fine. It's probably a bit faster. If it's common, then that's odd. I guess, I mean, you could, like, the alternative is using ints and then just carefully making sure that no variable is going to overflow. But I just don't want to do that because I'm going to forget to do that. So I just use long. But if it's faster and if it needs to be faster, then you can do that, sure. It works. Graph and tree questions? I have streams on those too, but like the easiest thing to do to practice the topic is like go to problem set, do like difficulty 800 to whatever, like maybe you want 1500 or something like that. Pick the topic. You can do graphs, and then there you go, and you can do everything you want. I don't know if they have a trees tag, do they? I think they might. Indeed they do, so you can do anything you want. Okay, oh, come on, I gotta continue, but I'll do a few more questions. Favorite college subject? Honestly, I'm in a bunch of like gen ed, like the generic classes that are sort of forced right now. Although I am taking a class on pirates, and that is a pretty fun class to be in. So I'll say that. It's called lawlessness. That is the idea of it. If you forget implementation, just practice it. You'll get it ingrained in your head. N64 and Long Long? I don't believe so. I think N64 is like the most rigorous, like absolutely you're getting a 64-bit number. And Long Long is like, I've never had an instance where Long Long didn't give me a 64-bit number. So I don't know of a difference, but there might be one. Phonic trees and segment trees, they just sort of fall under data structures. You can't really do better than that. Oh, Long is at least 64. Okay, hang on. Actually, no. Open the window later. Use Java so you can do CP and get Java as backend dev. Should I switch to C++? If you know Java and it's gonna work for you, then you don't have to. If you're like familiar with it and you're used to it, then no, it's fine. Linked lists, there is one use, and it's like, it's something like, I don't know. It's like basically where you want to delete elements in a certain order, and then you want to figure out like the previous and next elements. Then that's exactly what a linked list can do. But it's kind of hard to make it work. Why am I doing CP in college? Mostly for fun and for YouTube. USCO training does not have its own video tutorials. Happened to Div 4. I don't know, it happened once and then I think they decided it was a bad idea or something. It got a lot of backlash. Like if you read the comments, people were making fun of it left and right. Yes, I'm doing all of the problems in the stream. Eventually. It's gonna take a while to get there because there are so many questions, but eventually. Have I ever used short? Yeah. Do I have any mod int? I do not. I just use mod myself, but I'm sure mod int is like a good thing to have. Where did my message go? Okay. Alright, yes, I will do the problem. This one's also like fairly simple. So it's called ehab in GCD. You're given a positive integer x. Find any two positive integers a and b such that GCD ab and LCM ab is equal to x. So GCD is the greatest common divisor. LCM is the smallest or the least common multiple. I've gone over these. So how do we find such a pair? X over 2 works if it's even, but not if it's odd. Now, what you could theoretically do is you could find a divisor of n. Hey, right, hang on. Let me pull this up. A theoretical thing you can do is you can find a divisor of n. So say you know x where x divides n, then you can answer with x and n over x. And the reason is that, or sorry, n minus x. Wait, what? This should be an invite link, right? If it's not accessible, you have to sign in. I think that's the issue. If you're not signed in, it can't invite you because it doesn't have an account to invite. So if you have a divisor x of n, then x and n minus x will work. Because you know that n is equal to some sort of k times x, because that's like sort of another definition of a divisor. In particular, if we use the mod form I've been talking about, then n equals kx plus 0. But the 0 part is pointless. So n equals kx. So n minus x is really equal to kx minus x, which is equal to k minus 1 times x. So what I'm saying is this is going to be an integer. So n minus x is also going to be divisible by x. So x divides n minus x. And we can do that. And this will work because x divides n minus x, the GCD will be x, and the LCM will be n minus x. So we can find a divisor, it will work, but you can also notice that 1 is always a divisor. And so that's why this is an 800 and that's why it's a troll problem, because you can always have x equals 1 and it'll always work. So the number that always works is you can do 1 in n minus 1. But if you did not think of that, you could still do things like finding a divisor and doing that. But I think if you stopped your loop at 1, you would always print 1 in n minus 1 anyway. So like it's always going to work. So that should be good. The reason I'm printing spaces is because I'm lazy. And printing a new line takes an extra character to type out. But the point is, you can print any divisor, but 1 in n minus 1 will always work. So you can just do that and be fine. Sound good? Can I repeat it? You can rewind the stream, but like, I'm saying like, pick a divisor x of n. Use x and n minus x, and because x will divide n minus x, then x will be the GCD and the LCM will be n minus x. So the total will be x plus n minus x, which is equal to n. And you can select any divisor, but 1 is always going to be a divisor. So you can take 1, you can take n minus 1, and that's always going to work. Collab with William Lin. That is up to him. And then we'll have to see about that one. Anyway, those are the first two. You can see from the difficulty scaling that there's a sharp drop here. And I put cat cycle here because it is a notorious problem. Okay, hang on. Let me update the link. Does this work? No. It's worth a shot. Let me pin this. All right, so. Did I miss anything? What year am I in? First year of college. Well, I do the complex problems. Like, I'll do all the ones that are on here eventually, hopefully. Nah, I usually get through these streams in like 5 hours or something. It's fine. What's my future career? That is a good question. I'm not exactly sure. I mean, something in computer science, either some developer or like maybe some data scientist, but yeah, we'll see. We'll see how everything goes. All right, so problem C. I'm just sort of blinking. I think I'm gonna open the window. It's kind of hot in here. don't know how much that'll help. I prefer backend. I'm not good at visual design, as you can see by all my thumbnails, so I think backend is better for me. Okay, so I chose this problem because it is absolutely notorious. A lot of people, like, they totally just, like, died on this problem. Because if you can get lost in, like, you can get lost in the details and then it just becomes impossible. But I gave some advice for problems like this before. And the main thing I said at the... Yeah, this is the tutorial right now. The main thing I said for like this problem, or problems like this in general, is to model it as an equation. Because here you've got some like cats that are just moving, right? And it becomes a lot simpler if you think about it formally. So let's think about the cats. You got some spots 1 to n. Let's see, you have A over here, and you have B over here. Now what we're going to do is we're going to say, because the cats move circularly, like cat A will just wrap around, and cat B will also wrap around, that like, there's no end of the array, so it kind of just doesn't matter, like, it kind of just doesn't matter where they are. What matters is how close they are to colliding. So in particular, how close are they? Well, B is moving this way, and A is moving this way. So if you think about it like the distance from B to A, B would take 6 steps before colliding with A. And A would take 6 steps before colliding with B. So the overall like distance between B and A is equal to 6. Now, when a cat moves, B will move right, A will move left, the cats will move closer to each other. So this distance will decrease by 2 because B moves closer and A moves closer. I kind of didn't go over the problem statement, but I'm kind of going over it now. Basically, you have these cats, B starts at 1 and they'll move to the right, and then they'll wrap around when they're done. And A will start at the right and move to the left and also wrap around. And you want to find out, and if A and B are ever on the same spot, then B will automatically jump ahead 1 spot. So A and B can't really be at the same spot. And so you want to figure out when the final position, what the final position of B will be. And so it's basically equivalent to asking, because B will move k minus 1 spots forward automatically. So you know B is going to be offset by that, but B might also move like the amount of times that it intersects with A. So it's k minus 1 plus the number of intersects. So we know k minus 1. So the problem is finding the number of intersections. Right, so we know that the distance between them, after 1 move, it'll be 2 less than it was before. Once again, it'll be 2 less than it was before. And then now we get at this point. Right, so at this point, the distance between them is 0. Now, B is forced to move forward. Once again. K is input. That's just it. K is like the number of times they will move forward. K minus 1 is the number of times they will move. So after the distance is 0, B will move forward once again. And so now the distance between them, well, A has to travel 6 steps once again to get to B. So after it gets to 0, you get an intersection. And then the distance becomes 6 again. And this is why this problem works. It's because once they intersect, you basically just reset. If you rotate the array so that A is at the end, then you will have the exact same position where B is at the left end of the array and A is at the right. In particular, the distance between them resets to what it was in the beginning. So, what? How do I undo it? Okay. I don't know what I just did. I messed something up. But the distance between these two is going to reset after every time they intersect. So now, because it resets, the exact same thing will happen. So if you plot out like the number of intersections per move, the first two will be 0 because they just do what they want. And then the third one, because the distance becomes 0, there will be one intersection and then it will reset. So because it resets, the exact same thing will happen. There will be 2 moves with no intersections and then there'll be a 1. And there'll be 2 moves with no intersections and then there'll be a 1. And this is the case for all odd n. The pattern for n being odd, because of this, if you just trace it out, you'll get some number of zeros and then a 1. And the number of zeros you get is, I believe it's n minus 3 over 2. And that just becomes like, that just comes from the fact that like you get 7 and then you get 2 zeros. If you get 9, you get 3. If you get 5, you get 1. If you get 3, you get 0. So you can find the pattern there. But really this pattern, this whole pattern will last m minus 1 over 2 turns. And every m minus 1 over 2, like every m minus 1 over 2 turns that happen, you will get a single 1. So the answer for odd, the number of intersections you get is thus the number of full cycles that you complete. And a cycle is m minus 1 over 2 turns. So the answer then is the floor of k minus 1 divided by this stuff. Because it takes m minus 1 over 2 to complete a full cycle. And so you're interested in the largest number x, such that x times m minus 1 over 2 is less than or equal to k minus 1. And that's just because you're interested in the, like x is the number of cycles you might fully complete. And so this is the definition of floor, and therefore x is equal to that. So that's the number of intersections you get for the odd case. Now for the even case, it's even easier. And the reason is because they just never intersect at all. Let me show you. So you get B. After 2 moves, it's here. For A, after 2 moves, it's here. So the distance between them is 3. Then it goes down to 1. Then it goes down to -1. But really, like, they just wrapped around. So now, once again, we end up in the exact same position. Well, if we rotated the array, we would have B on the left and A at the right. And because the array is circular, we're allowed to rotate. So the distance between them is, once again, 3. And so we'll just repeat like this. The distance will be cyclic. It'll be 3, 1, 3, 1, etc. And it will never be 0, so they'll never intersect. So that's how this problem works. If n is even, there's no intersection. If n is odd, you get this formula. So you can read it to n and k. Note that k is 1 more than the number of moves that actually happen. So we have to decrease k because we're interested in the number of moves, not the number of hours. So if n mod 2 is equal to 0, then the number of moves you'll make imagine you start at 0 and then you get like after n moves, you'll reset to 0. So really it's like every n moves you reset to 0. So essentially it's like taking it modulo n. And with circular arrays, it really is just like modulo the length. which is sort of a common theme. So, yeah, with circular arrays, like that's kind of how it works. So in this case, the circular array is size n. So the index will be, you start at 0, you move k minus 1, and then you get to n. So the answer here would be k minus 1 mod n. But here we do need to 1 index because that's what the problem says to do. So index 0 is actually 1, meaning we need to add 1 to all of this. And note that I've already decremented k here, so we don't need to do k minus 1. So the answer is 1 plus k mod n. There we go. Otherwise, n is odd, and so we plug in this formula. Count the number of intersections, which is k over n minus 1 cout 1 plus. The reason we're adding k to intersect is because we already do k moves, and then the amount of times we move forward extra is just the number of intersections. Seems good. There have been a lot of wrong answers on pretest 2, though, or wrong answer on test 2. But yeah, this problem is notorious, but it goes down fairly reasonably if you model it like an equation. If you formally think about the distance between the cats, then you can arrive at something like this. Cool. So, yeah. I guess we'll get to D. I have to reset this every time, huh? Pin that. This rating was 1200, which is surprising, but it comes from the fact that a lot of people did eventually solve it. It just took a much longer time than usual. And generally problem rating comes from the number of solvers, I think. I don't know, maybe it does have to do with the time too. But I would generally assume it just has to do with the number of solvers, not the time it takes for people to do it. Okay, this one is arguably easier. You have n people sitting in a circle, they're numbered from 1 to n. And they're like adjacent in the way that you would expect them to be. So 1 is adjacent to 2, and etc., and n is adjacent to 1. So 1 initially has a ball, he picks a positive integer k, and then he throws it k to the right. And then that person will throw it k to the right, and that will continue on until you eventually get back to 1. So this is an example of it. And then when it gets back to 1, the process stops. So I guess, yeah, sure. So this problem defines a value of the fun value, which is basically, if you consider everyone that had the ball in their hands at some point, you sum up all of their numbers. So in this case, the fun value would be 9 because the people that touched it were 1, 3, and 5. So what you want to do is, you want to find out, for every possible k, the different fun values. So if 2 fun values are the same, then you would not report them twice, you would only report them once. So for example, here there are multiple ways to get 21. You could, for example, do 1, or you could do 5, and they would both end up in the same way, because 1 is essentially throwing it forward 1, and 5 is essentially throwing it backwards 1. So you would end up with the same set of people, but you don't do it twice because you get the same number either way. Will this collection be there? Yeah, it's right here. If you click on this pinned message, then that'll just take you right to it. Although some people have had trouble accessing it, which I'm not sure exactly why. Like if I click on this link, it's fine. It should work, but I'm hearing that people are having trouble with it, so I'm not sure. How much time do I spend on one problem? I spend as much time as I want to without feeling tired of it. If I feel tired of it, then I will stop. But otherwise, I just do it until I am tired of it. That has been my strategy for like forever. Although it is probably beneficial to cut it off at some point and try some other things and maybe read the editorial if you need to. I don't recommend it for everyone, but it's been working for me. Okay, this problem I picked actually sort of to torture myself because it's not hard to get the concept, but it's sort of hard to prove, I think. Although it kind of isn't, I don't know, it kind of depends on how you think about it. So, let's think about 6. They go through all the cases. There are 4 different values. 1 is you go through everyone, 2 is you make this triangle, 3 is you make this straight line, 4 is one just throws it to himself. So think about like a bigger case. Oh wait, should I think of a bigger case? Yeah. So we can do something like 10. So let's do 10. 2, 3, 4. Nope, wait. Yeah, okay. Draw it this way. And that should be 10. So person 1, we'll consider like throwing 2. So person 1 will throw like this. If we throw 4, we'll end up like this. If we throw 6, we'll end up like, well, we'll get the same thing but backwards. And if we throw 8, we'll get the same thing as 2 but backwards. And the idea behind this is, we're asking how many people are eventually going to be visited. And the answer is that it's easier to consider 1 as just 0. And we're going to be able to visit everyone where, if our throw is k, right? Then the amount of people we're going to be able to visit is the people where the GCD, or rather, we'll visit I, where I is divisible by the GCD of k and n. And like one way should be simple because both k and n are divisible by this GCD, meaning that any multiple of k, so like every index you get is going to be essentially representable by some x times k, and then that mod n. So x will be, for example, 0 or 1 or 2, etc. And note that x times k mod n is really just subtracting and adding n a bunch of times until you get within a certain range. So because k is divisible by this GCD and n is divisible by this GCD, every number is going to be, every possible like number that you can get from here is going to be divisible by this GCD. Since k is equal to like like say the GCD is like g or something, then k is equal to ag, n is equal to bg. So x times ag mod BG is what you get. And so everything you do is just going to have this G in it. I don't know if that helped, actually. I'm not sure if it did. But every bit of arithmetic you have, like, everything is going to have this factor of G in it. So you cannot visit anything where I mod that GCD of n is not equal to 0. And the other part is saying that we're going to visit everything with this GCD. And this comes from, I think it's like, what is it? I believe it's like Bézou's theorem or something. Subtitles? I think they should be automatic, although I'm not sure. Sometimes it doesn't happen. So I'm sort of just proving this, I guess, that the only locations we're going to visit are the ones that are divisible by the GCD of k and n. And again, the reasoning here is, one, we've shown that there is no way to like visit something that's not divisible by it, because like every possible number that you'll visit will be divisible by it. And now the other part is showing that like we have to visit everything, right? Extended Euclidean GCD. That comes later. Or Bézou's theorem is pretty related to that. I think extended Euclidean GCD will solve for a solution to Bézou's theorem. So like essentially it says for any a and b, I think it's a and b, there exists a solution to the equation ax, there exists a solution pair xy to the equation ax plus by is equal to GCD of x and y. Right, so here in this case, the a is equal to k, and the b is equal to n. And the reasoning for this is because we can take any multiple of k, because we can have any x. And the reason we have freedom over n is because modulo is essentially adding and subtracting numbers. Like modulo n is essentially adding and subtracting n until we get within the range of 0 to n minus 1. So because we have free reign over x and we have free reign over n, essentially we can just have this equation and it'll be fine. We can add or subtract k as much as we want, we can add or subtract n as much as we want. And we want to get to GCD x and y. And the theorem just says that there is going to be a solution. There is going to be a solution to this. And in particular, because we know that we're doing mod n, y doesn't really matter. What we're interested in is x, because x will tell us the value of x in this equation. But even that, like, it doesn't really matter. Really, we just need a solution to this. And once we have a solution to this, then we can achieve any multiple of the GCD, because we can take like some value. Say we want, for example, z times the GCD of x and y. Or this should be a and b. That's my bad. These should be the input arguments. So it should be z times the GCD of a and b. If we want that, then we can simply multiply this side by z2. So we can say z times ax plus by is equal to z times GCD of a and b. Then the solution we just take is we take a times zx plus b times zy. And so really that means that the value of x we would want is zx here. So essentially within this cycle, because there is always a solution to this equation, we will always be able to visit everything that's divisible by this GCD, and because once we get back to 0, we're essentially just starting the cycle over again, that we have to visit everything that we can visit in the first loop before we get back to 0. So there is always going to be an x that satisfies it, and because we can visit it, we have to be able to visit it. I think that should cover it. Does that make sense? I don't know. I'm trying to think if that makes sense. It's sort of an involved proof. I don't really like it. It's sort of intuitive. I think I sort of just guessed this problem when I did it a while ago. Like, you can guess that the GCDs matters, and you can guess like maybe you can visit every part of the GCD, and it just turns out you can. And the reason is because you can take a solution to this equation and you can apply it. In particular, you would use Zx mod the length of the cycle here, and the length of the cycle is n over GCD. So this will be mod n over g. And this would give you what you want. Okay, I think that's enough for this. Okay, so I've sort of shown the main idea. Now we need to do like actual code. So every GCD, first of all, is obtainable because if we just iterate over the divisors of n, then if we set k equal to that divisor, then immediately we'll be able to get that GCD, because the GCD will just be the divisor. So overall divisors of n, overall divisors of n, essentially overall possible GCDs. So like iterate over g. So for some g, what we're going to do is we're going to start from 0, or in particular we're going to start from 1. We're going to go to g plus 1. We're going to go into 2g plus 1, 3g plus 1, etc. And it might even be easier to just take out the 1s. So actually it's like the sum of these. So actually, I think it's easier to start at 0. So we take 0, we take g, we take 2g, we take 3g, etc. up until n over g minus 1 times g. And so really, it's g times the sum of 0 plus 1 plus up to n over g minus 1. And also, we need to add 1 to all of these. And there are n over g terms. So overall, we would add n over g to this whole thing. This is something we know how to compute. It's like, I believe should be just n over g minus 1 times n over g over 2. I'm still thinking about this. Yeah, so we do that for each divisor, that's our answer. I'm still thinking about this proof though, that's the thing. It feels kind of unsatisfactory. Like, if you imagine if we didn't stop at 0, then we would be able to visit everything, because eventually we would stumble upon this value of z. I guess the idea is like, when you stop at 0, you would cycle back to 0, and then the entire thing would repeat again. So if you don't visit it on the first time, then you will never visit it. But we know that we're going to visit it eventually, because eventually, like, we have to stumble upon this z. So everything has to be visited. because we would visit it eventually, and the only eventually is the cycle that we're in. I guess that's how you would explain it. Yeah, sure. It kind of makes sense. I don't know. So code is like, after all this, the code is like pretty simple. We go over divisors of n. I'm going to use my template here. Go into number theory. I'll just leave this in my code the whole time. I think that would help. So we put in number theory, and then all we need to do is divisors. Now, for each divisor of n, the answer will be so I'll use G here, since this is the GCD. It is length. The length of the cycle is n over G. So G times len times len minus 1 over 2 plus len. Get unique just says like make it unique. This is something I copied from Stack Overflow, but I never bothered to memorize. So it just makes it so like everything, it keeps like only one copy of every element. What? What? What the hell did I do? How does the editor even have capability of doing that? I don't understand what that functionality is. 6. Multi-tests, I assume. One, 5, 9, 21, 16. There we go. Looks good. Overflow could be a thing. I don't care. 10 to the 9th. Wait, actually, that could be a thing. No, it could not. Because G times N over G cannot be like that big. Because G times N over G. Like, that's just N. I'm going to try to cover everything. Viewership is low because it just conflicts with a contest, which, of course, like, why wouldn't it? But, yeah, I'll go over everything. Anyway, this one seems fine. Am I? I'm not a manager, right? No, okay. So if you look at standings, what I want you to be able to see my solutions. I also hopefully enabled it so as a participant you can just click on any solution and see it. That should hopefully be the case. If it's not, please let me know. Let's do problem E. I think it's Coach Chef starters. Someone mentioned that. It should be like, wait, is this? I don't know. I heard about a Coach Chef starters. Yeah, it's like going on right now. Ends. Wait, what? When did it start? Wait, did it get extended? Yeah, it got postponed. Awesome. Freaking Code Chef. Of course it got delayed. Why wouldn't it? Bit of advice. I guess just like learn math. I mean, if you don't, a lot of starting it is just like generic problem solving skills. Just being able to think about a problem in your head and like just trying things. So if you can't solve problems immediately, then I would recommend, I guess, look at editorials and see how people look at problems and then try and mimic that. A lot of editorials are not good enough for that, admittedly. I try and do that in my videos. I'm not sure how good of a job I do of it. But the goal of it is not to see just the solution. You want to see like how other people look at problems like that. And then try and emulate that for yourself. I don't know. The best thing to do is look at someone who's like not read for that, because it's not like, these problems are just sort of instant for me. Like all of the intuition and stuff just goes on in my head immediately, and it's kind of hard to explain. So I think it's better to consult someone who's much closer to your level, who doesn't necessarily struggle on the problems, but they understand what it was like to struggle on them. Because then they could tell you like what they did to get over that. So I don't have advice for being able to solve easy problems, because I'm honestly not sure. But I think the best person to ask would be someone who's close to that level. Like maybe you would ask like someone who's green, or someone who's at the upper echelon of gray, or maybe a specialist or something. I think that would be better off. What order? These are roughly ordered by difficulty. You can also go by solve count, either way. Don't start with the last problem though, would not recommend that. Let's see, problem E. By the way, if you want to do the contest, like go ahead, it's totally up to you. This stream will be available like as an archive, so you absolutely do not have to watch it live. Like all of my streams, I have this whole playlist here of like just every stream that's happened in the past. In fact, this one's happening right now. I actually meant to put this in that playlist. Let me go ahead and do that. There we go. I mean, starters is happening once. The stream you can watch anytime. I don't know. There's also, by the way, there's also a Q&A by Umnik. I think that is probably pretty valuable. So that should be interesting to tune into later on. I'll try and get through these problems fast so it doesn't intersect. I don't know how fast I can be. So, next problem is called math. Essentially, given an integer, you can multiply it by something, or you can take the square root of it if the square root is an integer. You want to find the minimum value of n. Right. So, this one's kind of weird, but it becomes easier if you start thinking about it in terms of prime factors. I'm not exactly sure how you would get the idea of thinking about prime factors, but if you do, it becomes very reasonable. And the reason is like, it's easy to solve for a single prime power. Because think about just like, think about having like a prime to the k. If you square root it, then you get p to the k over 2. If you multiply it by p to the x, then you get p to the k plus x. So really for a single prime power, you have two options. You can divide it by 2 if it's even, or you can add some value x to it. You want to make it as small as possible in the smallest number of operations. And the way to do that is simply, well, you can only divide by 2. So the best you can do is k equals 1. If you don't have a prime factor at all, then obviously you don't want it, because that'll just add some number in. And if you do have a prime factor, then what do you do with it? What you'd want to do is, for example, say you have 6. The way to get 6 to 1 is, maybe you could divide by 2. And then what you need to do is you need to raise it to essentially it's the nearest power of 2. So you would raise it to 4, and then you would divide that by 2, and then you divide that by 2 again. So the easiest thing to do would be to initially raise it to the nearest power of 2. So here, for example, you would get 6, you would go to 8, you would go to 4, you would go to 2, and then you would go to 1. And the reason that's nice is because here, then once you raise it to the nearest power of 2, you only raise it once at the beginning. Then you don't have to divide it again, and then you don't have to keep raising it again and again. You just do everything you need once at the beginning, and then you're done. Another way to think about it, to realize why this is optimal, you can think about the operations in reverse. You can multiply, you can think about it like you start with 1 and you're trying to get to 6. In one move, you can multiply k by 2, or in one move, you can subtract some number. So the first thing you have to do is get to larger than k. So here in this case, you would keep going until you get to a number larger than k, and then you only have to subtract once at the end. So if you think about it in reverse, it sort of makes it clear why this is the best thing to do. But the point is, for this single prime factor, what you would do is you would raise it to the nearest power of 2, and then you would divide it. If it's already at the nearest power of 2, you save an operation. You do this separately for every single prime factor. Now, this is nice because multiplying by a number means that like you can simultaneously handle every single prime factor at once. Like for example, say you have 2 to the what's the sample? 5184. Let me just do that really quick. 2 to the 6 times 3 to the 4. So if you have 2 to the 6 times 3 to the 4, that is a good sample actually. That is nice of them. If you have 2 to the 6 times 3 to the 4, 6 you would raise to 8, 4 you would raise to itself, but because you're raising 6 to 8 and you're gonna do 3 square roots, you have to raise 4 to 8 as well, because otherwise you would not be able to square root 4. So first you find the highest power of 2 that any prime factor has, and then you have to raise everything to that power. And then from there, once you raise everything to that power, then you can divide a bunch. And then like, once you raise everything to that power, the number of moves you need is log base 2 of 8 in this case, or just the highest power of 2, because it's just the number of times you divide by 2 until you get 1, which is the definition of log. So the algorithm would be, for each prime factor independently, or like, first find the highest power of 2 among all of the prime factors, raise everything to that, and then take the log, and that's the number of operations you have to do. And note that if everything is already that power, for example, if you have 2 to the 8th times 3 to the 8th, then you don't need to raise anything and you save an operation. So here you would do 4 operations, here you only need to do 3. So hardest part is factorizing at all. Let's just do that really quickly. I have a template that does it. It implements everything. I implement sieve, and then with that sieve, I create a list of primes, and then I use that list of primes to factorize the number. It works in O of root n over log n. I went over that in the prep video that's right here, so you don't have to. Wait, this should be the right one. Yes. Okay. I went over the prep video in here, so like you can do that. So vector x is equal to factors of n. We're also going to map these values to a count array. You don't need a map because the values are small enough, but I don't care. Then we're going to store pairs of value count, in particular primes. This will find prime factors. At some point I will document this template, but it has not happened yet. Alright, so now what we do is we find the largest of the prime factors. Can it be 1? It can be 1. Let's test that. For LLX count, Worst is equal to max. Worst. No, wait. This is pairs. X.S. X.S is the count. So we're taking the largest count, and then let's find the power of 2. Let's see. How exactly do I 2 to the b is less than worst increment. So then the operations we need to do is b, and if any of the prime factors at all are not the same, if any of the prime factors are not equal to this power of 2, we need to raise them, so we lose we have to do another operation. If x.s is not equal to 2 to the b, then they are not all the same. And so we have to do an extra operation. So if not all the same, plus ops. We find the product themselves. For every prime factor, we will use exactly one of them. So we just take exactly one copy of that prime factor. And there we go. Do I have Pollard's row? I do not, but I did in this video. I linked
Become a cybersecurity
something that will. I linked this, which is a very powerful factorization library. This is the library of an LGM, so it's like pretty good. But yeah, I don't use that, but that library is probably what I would copy paste if I needed fast factorization. And in fact, I have cheesed the problem using that, so that is cool. Yep. I left this message for myself because you need to sieve to use the factors method, and sometimes I just don't do that. So I'm glad I did this, because otherwise, you know, it'd spend a while. If you get called a dope, it's because I'm calling myself a dope. If you use this template, by the way, that is my own fault. So we gen primes up to like, should be enough to like only square root of n. 20. 5196. That's not the right number. 5184. 64. Test 1. 2. Okay. Um, 20K subs. Good question. I do not have a current plan. I will think of something. Why are you running on test 7? Okay. Yeah, 20K subs. I don't know. I'm open to suggestions. I've found that whenever I set a milestone, I usually blow through it. For example, like, here, let's take a quick detour. I set a milestone for 26. Jesus. I set a milestone for 2622. Oh yeah, I usually do this too. I usually update the subscriber count. You know, my goal was to eventually get a memory limit exceeded from all the subscribers. I'm not sure if that's possible, but I will try. Here, right. So my initial goal was, like, you know, YouTube actually like gives you this like over time thing, which is pretty cool. So my goal initially was to blow through. Wait, where is this? My goal initially was to blow through 2622, and right then, if you'll look, this is when I uploaded the journey video, and I got like 600 subs in 2 days. So we completely blew past that milestone. I think I set another one for 5K. That was, I think it was around, no, actually I didn't blow through 5K, but 5K was around the time where I, wait, what happened here? Oh, right, this is when I started streaming. So 5K was around the time where where I did, I think that was the duel versus second thread. That one was pretty good. That one was a nice boost. And then I set a milestone for 10K after a while, and that was when I uploaded the black box video. And here I got around 2,000 subs in just a couple of days. So that was totally insane, and we just completely blew past this. And so now, hopefully if I set to 20,000, was like go off the roof, you know? You can see this just like totally skyrocket, right? We'll see about that though. I am always on the grind, that is true. Ignore that. Complete Grandmaster course. Perhaps. That will be part of the ladder that I eventually do. We'll see how that goes. E was easier than D? Yeah, maybe. I don't know. It's sort of subjective. Certain things are just easier. I mean, D has more solves, so I don't think everyone agrees, but I think like it just depends on what your strengths are. Why we cannot take maximum power? Because you have to divide by 2. So it has to be a power of 2 since you have to divide by... The only thing you can do is divide by 2 a bunch of times. If that's what you mean. Time complexity for factorization. That is the number of prime factors you have. And the number of prime factors is the worst case is you can have a power of 2. So for example, like prime factorizing 2 to the 30th is O of 30. So in general, it's the worst case is O of log 2 of n to prime factorize using the sieve. I don't think that's Miracle 03. There's no way he would ask that. Let me see. Hang on, I'm trying to answer the questions in order, so I don't lose myself. Is it okay if you discuss the code of other people and do it yourself again? If you're learning, then it's sort of equivalent to learning from the editorial, which is generally fine. How to improve from newbie? I honestly don't know how much of an influence cheaters have, but if you get good enough, you will beat the cheaters. There is a point where you're just better than everyone that could possibly cheat, and that ultimately is the point you want to strive for. But like, the cheaters are not going to hold you back. If you get good enough, you'll be able to beat people. I think. Because I mean, people are still improving like all the time and stuff like that. And maybe it's a bit harder, but it's only like, I don't think it should be that much more difficult than it used to be. Which MacBook? Let me find that out. It is the 2021 something. No, that's not what I meant to do. About this. Now my mouse stopped working. What the hell? How is that a side effect? What the hell? How is that a side effect? My mouse just stopped working immediately after I did that. What did I do? What did I do? That's not what I meant to do. That is an old picture of me, by the way. About this Mac. Here, there's the version info. How did that possibly mess with the mouse? I don't understand. I'm just gonna, okay. You know, my fix with my old mouse that used to just like die on me was just to take out the battery. And I did that like over 100 times because it would die like every few hours or something. So I'm just gonna try that. Old tried and true method. I think I have batteries here, but I don't want to use them yet. I forgot to turn that off. That could have killed me. Okay. Take programming advice from me, not life advice. You guys got that? And do anything. Trackpad's weird. It has like 2 different levels of click, and when I try and select something, it like here. This is what happens when I try and select something. It it decides that it wants to open the dictionary for everything I click. I can't get around it. Cause I have to drag, I have to tap ever so lightly to be able to use the trackpad. It's so weird. Alright, wait. Okay. Should we actually do no mouse challenge for the rest of the stream? What do you think? This just stopped working. I swear to God. Alright, no mouse challenge for F. Let's go. I don't think it'll make that much of a difference. Oh, you can turn it off? Okay. Yeah, honestly, I just need to spend like a whole day and just look at the settings. Wait, how do I turn that off? I kind of want to do that now. Yeah, because if I'm gonna use the no mouse challenge, I want to it's kind of a pain. No loops challenge? I mean, you can wrap everything in recursion, or you could you can wrap everything in recursion. Someone provided a template that simulates a loop, something like that. Okay, system pref trackpad, got it. Do you know why that disabled my mouse, by the way? Trackpad. This? No. What is it? Point and click. Which one is it? Oh, force. I see. Okay, let's try that now. Ah, awesome. Wait, did that change it physically? Oh, that's cool. Alright, thanks. Yeah, that changed it physically. That's weird. Because it used to there used to be 2 levels of click, and now there's only 1 level. Interesting. Let me do a no loops challenge. No, not for this one. This one I need factorization. Oh, now my mouse started working again. I don't know what changed that, but I guess that's cool. Alright, we're still gonna do no mouse challenge though. So this one, did I did the thing? I don't think I did. What's haptic wait, so they vibrate it exactly so it feels like you click it a second time? Is that what you mean? If so, that would be crazy. Oh, Oscar, back at it. Wait, I don't know what's up with that. I remember someone else said that, and I didn't get anything from it either. So maybe if that happened, it probably didn't go through, because look, it's not telling me anything here. And we don't, by the way, I do appreciate it. You don't have to, it's not necessary to just by the way, just for everyone. Do I have GF? No. You got the email? Maybe it just takes a while to go through. I don't know, it's possible it's delayed. What do I do to debug? Okay. Before we go to this problem, sure, I can say that. I also don't know generating functions, so either way, the answer is no. So debug, first thing I do, just look over the code. Look at every line, make sure there aren't typos, make sure that everything is as I intended to write it on the screen. And if that's the case, then I can conclude that the code correctly reflects the idea that I'm thinking about. And so if the code is right, then the problem is the idea. And so once you conclude that your code is right, you need to break down your idea and you need to find out what's wrong with that. So how do you break down your idea? Well, I mean, your code is a bunch of steps, right? And similarly, your idea is a bunch of steps where one step will lead into the other, and you sort of like draw conclusions like from that. So to break down your idea, you just need to think about every single step of your idea independently and make sure it's right, and make sure that your idea sort of like flows. That if one part of your idea is true, then that also means that like everything else about it is true. And so like you wanna think like critically about your solution. You want to make sure that every possible aspect of your solution is right. And if you find something that's wrong, then figure it out. Like figure out why it's wrong, figure out how to fix it. And if even that doesn't work, if you're totally convinced your idea is right and your like code is right, then stress test. I guess that's probably the only thing you can do. Honestly, this is not something I do because I don't have a stress. Actually, it's what I do except for the stress test part. I don't have a nice stress test system. I've been too lazy to do that. But that would be what I do. Eventually, I just turn to the stress test and hope it finds something. And stress test is just you test a bunch of test cases. That's it. How are generating functions easy? What are you talking about? I think you're just lying. You're just lying to me. I don't believe you. All right, meaningless operations. Let's go. You have an integer a. You want to choose b to maximize this quantity. Right. I do not get everything in first try. That's totally a lie. Oh, debugging flags. I'll show you my compilation command. If I can remember where it is. I think it's users, Galen Colin, CSHRC. Here, this is what it is. Yeah, I'll just paste that here. That is my compilation command, so you can use that however you want. If some online judge decides to define Galen Colin local, I'm going to kill someone. That would be funny though. That would be a funny prank. I'm not using Vim. I'm using a thing called TextMate, and it's because it's the first thing I found on Mac. How many viewers would survive it? Dude, I would have single digit viewers from generating function stream for sure. Also, I remember you, just didn't acknowledge you. You're welcome. Yeah, straight up single digit viewers. Like half of the people wouldn't even know like what the title means, probably. Or I don't know. I doubt it would get that much traction. Maybe in like topic stream like 74, like we'll eventually get there. Who knows? I doubt we'll get that far, but who knows? It's odd to think there's a limit of the amount of topic streams I will do in my life. This could be the last one, who knows? Probably not, but who knows? I do Q&A, like all of these streams are basically Q&A. You can ask me anything, I'll probably respond to it. I'll do a formal Q&A stream like soon. Like by the normal definition of soon, which is like soon. So you want to pick a B, you want to minimize this quantity. Okay, I'll reread the statement again. You have an integer A, you want to pick an integer B to maximize the GCD of A XOR B and A bitwise and B. I have gone over bitwise operations before, so if you want to know what these are and understand them, you know, stream. So like, I always zoom the wrong way. You always notice I always zoom in before I zoom out. It's just, I always forget which way to do it. I always do it wrong every single time. Like, that's out. Down is out. It just inverted. It's still weird that Mac like inverts the scrolling. So maximize the GCD of these. First thing to note is that the GCD of anything in 0 is 0. And so what if, for example, actually no. Well, we can't set b equal to a, but if we could set b equal to a, then a XOR b will be 0 and a and b would be b. And so that would give us the answer of b. But so we can't make the XOR 0 because we can't set b equal a. But what if we made the and 0? So for example, say we had like b equals like 21, that's a number I like to use, which is 10101. To make the bitwise and 0, what we would do is, yeah, GCD of x and 0 is x. Oh, did I say 0? Yeah, I meant x. So to get a bitwise and of 0, essentially none of these bits can be 1. So all of these bits have to be 0. And then we have these 2 blank spots. And notice that because the bitwise and is 0, we're really just maximizing a XOR b by setting these bits to 0 or 1. But because we know that these are 0, what we want to do is we want to have these bits be 1, because that way the XOR of these will be 1. So essentially we set every bit to the opposite of whatever it is in b. So in that case, that would make the XOR 1 for every single bit. I did not get anything. Am I just, what is happening with YouTube? I swear, someone else did that. Someone else had that exact same issue. I don't understand it. But no, I didn't get anything. That is weird. I see the button, like it's enabled. I don't understand what's wrong. So Max, let me just wrap this up. I keep interrupting stream. People have been complaining about that. And I mean, I understand it. So if you have these zeros, then you can set all of the ones to 0, and then so the XOR will have every single bit be a 1, and the AND will have every single bit be a 0. And so the GCD is, it ends up being like every single bit in B can be set to 1. So it's like the most significant bit of B, and it's like 1 above that minus 1. So it's like 2 to the ms, 2 to the most significant bit of B plus 1 minus 1. Because that just comes from the formula of like all of these are 1. And that's just the formula for like an all 1 number. That it's 2 to the larger bit. Yeah, it's 2 to the larger bit. So, okay, sorry, I'm just getting lost. So that is the answer for most of the cases. But the problem with this is, what if B is something like 15? Then all of the bits are 1. So we can try setting all of these to 0, but the problem is that doesn't work because B has to be between 1 and A minus 1. B has to be positive. So this doesn't work if the number is all 1s. And this is the other case of the problem. And the answer here is when we set a number to x. So for example, say we let a equals 5. Then we'll have 0, 1, 0, 1. Essentially, the bitwise AND will be 5. Because every bit in A will be set in B as well. So the bitwise AND will be just whatever A is. I don't know what that is. A bitwise AND B is equal to 5 because we just get 0, 1, 0, 1. And the XOR, every bit that's set in A will be subtracted from B because all of those bits were initially 1 and now they're becoming 0. So A XOR B is equal to 15 minus 5. 15 minus 5, since these bits are going to be 1, 0, 1, 0. So when b is a power of 2 minus 1, a and b is equal to a XOR b is equal to b minus a. So we're looking for the maximum of the GCD of a and b minus a. Note that this is similar to the form we had in a, where we have some number and we have a multiple of that number. And here, here the best thing to do is to take a divisor of b, because otherwise the GCD will be like messed up. But if a is a divisor of b, then b minus a is also a divisor of b, because b is equal to k times a for some k, so b minus a is equal to k minus 1 times a, and so we get the GCD of a and k minus 1 times a, which is a. So the best thing we can do is take a divisor. Because if we have something that's not a divisor anyway, then it can't possibly be the GCD of like two numbers that sum to b. That can be proven. So yeah, that's how this works. So if it's not a power of 2 minus 1, make it a power of 2 minus 1. And if it is a power of 2 minus 1, you go through divisors and find like the biggest one. It is the largest divisor, right? That should just be it. It should just be the largest divisor, I think. Right? Yeah, I believe so. Yeah, it's just the largest divisor. So C and N. I'm not going to use, actually wait. No, I can do it. So from the bitwise stream, you may have learned that the formula for finding the most significant bit is the number of bits in the number, in this case 64, minus 1, minus the position of minus the number of leading zeros. I inverted A and B. A is the smaller one, so like that and that, right? Am I wrong? Not exactly sure. Count the leading zeros of n, and then let's see, what do I call this variable? So the power of 2 minus 1 is equal to 2 to the power of the most significant bit minus 1. If n is equal to this power of 2 minus 1, then we get this like annoying case where we have to deal with stuff. And otherwise, if n is not equal to that, then the answer is just that, because we can do this. We can have these be 1, we can have these be 0, and everything will work out. Otherwise, look for the largest divisor. I times I is less than or equal to n, I plus plus. If n mod I is equal to 0, ants is the maximum of ants, and we know we get I as a divisor, we get n over I as a divisor, but because I is less than square root, then n over I will be more than square root, so the only divisor we consider is n over I. Because we can also take I here, but again, I is small, n over I is better, so we only care about n over I. When you want the best. Multi-tests. 113. Y. Oh. 2 to the MSB plus 1. My bad. That's the formula I meant to do. Why are you 3? That's not right. Wait, what? Oh. We should not consider 1 as a divisor, otherwise we just get n, of course. I want the largest proper divisor of n. And proper means any divisor that's not the number itself. So let's test with something like 15. Should get 5. There we go. We're good. Let's go. How many hours do I practice daily? I mentioned that before. Before, when I was like really grinding, it was like anywhere from 2 to 8. Now I just think of problems whenever I have free time when I'm interested. But it's like, I don't know. Recently it's been like 1 or 2 at most. It's not been that much. But it used to be a lot. Yeah, I did not get the donation. Okay, I want to look into this now. Because this is a problem if people are sending money and it's just not going through. That is very bad. I don't know what's up with that. Have I... Let me look into this. So monetization and then supers. Like straight up, it's enabled. I haven't gotten anything but that first one. Is this like a known thing? Like YouTube donations paid but not going through? Is this a problem that people are having? How long does it take? Okay, that's not right. I don't know. I don't know what's up with that. Honestly, I don't know. I don't know why that's happening. How do I cope with school? Just grinding. Take care of school stuff first, and then... No, there was no super chat. That's the thing. It didn't... Apparently it was sent and paid for, but it didn't go through. Which is really weird. Yeah, coping with school is just like... I mean, you have enough time. If you're able to, like, get through your work and stuff, you'll probably have enough time to do both school and, like, do free time and stuff. It's just kind of hard to get that time. I'm thinking about making a video on, like, a trick for focus I've been using. What do you guys think about that? I think it's, like, it's sort of a different style of video, but I think it could be helpful if it's done well. You guys think that could be good? Any suggestion for DP? Practice it. I don't know. Learn the... I mean, the generic answer is practice. Like, learn the common methods and then, I guess, apply them. Because they're kind of hard to come up with. What trick? You'll see in the video. You'll definitely see in the video. Yeah, if I spoil it now, then it's not going to get views. I need it to get views. So I will let that wait. I'm sorry that the donation didn't go through, though. I'm not sure why that's happening. And like I mentioned, people have had that. I don't understand what's happening. I need to... I don't have a... What is it called? Like a partner manager, but... I don't think you get that at 10K, but like there should be someone I should be able to talk to figure that out. Yeah, you could probably get a refund from YouTube itself. I'm not sure how that works, but they have to have something for that. Because there is clear evidence from this stream that it never went through, and if you need, I can help you verify that it never went through. That's really weird. What else did I miss? Practicing 4 to 6 hours. Okay. What kind of practice are you doing? How much time do you spend on a particular problem? Is it normal to feel like giving up? That is a tough question. It depends on the motivation that you have. If you're doing it to get good, then it's going to be a lot harder. That's the thing. If you're doing it to get good, then your motivation is based on results. When you don't get results, you'll be disappointed, it'll be demotivating, stuff like that. It's just harder in general. If you're doing it because of some inherent interest, and you're really just interested in it in general, then that is the best way to get good at something. When you don't care about how well you're doing, you just enjoy doing it. Because then you'll just enjoy doing it, and it doesn't matter. So I think one thing to do is to rethink the motivation, like that's the rethink the reason why you're doing it, first of all. And 1 hour on a problem, I guess that's fine. I guess a good way to measure if you're learning is see if you can try, look at past problems you've done and see if you can solve them again. In terms of measuring how well you're doing, instead of rating, I think that's one of the best things you can do. You can tell if you're learning from a problem if you're able to solve it again. If you can't, then you didn't get enough out of that problem. That's something. What resources? I mean, you could do my streams, you can do like... For any particular topic, there's probably something that can... There's probably a video on it or something, or some tutorial on code forces. Oh yeah, wait, okay. If I had to recommend a single resource, usco.guide. That is like... It's like the... I think it's... I don't know, I feel like it's underrated. It's like, literally like... If you're looking for a roadmap or something of topics to learn, that is just it. This is just everything. This is just so much organized with problems and explanations and stuff like that. So usco.guide. If you want a resource, that is a great one. Actually, I can't testify to its greatness, but I've heard it's good and people trust it. Yeah. Just usco.guide. I'll linkify it. There we go. Video with... I have answered with... Okay. I have answered... yes. What? Do a video with William Lin. Because I don't know. That's mostly up to him, I guess. CP algorithms, yeah. 11:37 p.m. Yeah, honestly, the problem with streams is that for most people, especially in India, because that's like my main audience, my morning is your night, and that's like really a pain. Because any midday stream, I just can't do that because it's just in the middle of the night for you. A lockout? Oh, what are you trying to do? Get me killed? I'm gonna go to the next problem. You're trying to kill me, I swear. You really want to see that happen? It's gonna be like, I opened the problem and he's already solved half of them. That's gonna be how it is, seriously. If you saw that video with Nick White, which is pretty funny, I think you'll get a similar scenario. Like we are, even though our rating is not like numerically like not that far, there is a vast difference between us. Yeah, 9:08 p.m. My time to IST is you take my time, like invert it and then subtract 2.5 hours. I did beat him in that one Kickstart, but the amount of times he's beaten me is like unbelievable. Or like the amount of times he's beaten me is way more than the number of times I've beaten him. It is very improbable that I will beat him again, at least for a while. Just based on how the probability of rating works. I did use that thumbnail though. That was something I milked. A lot of people told me to do that. I don't think daylight savings has happened yet. Has it? Wait. No, I don't think so, right? November 7th. No. Okay. So that's like later. I'm EST or ET or EDT, whatever that is. Did I have Math Olympiad? No. In fact, I hated math when I was young. Yeah, I am in Maryland. It's like Eastern time. That's what the time zone is called. I don't know why it would be in New Jersey time. Is it New Jersey? I think. Alright, this problem is contrived and I don't like it. But it is a problem. So, I don't like it, but I think it's valuable to know. So here's what it is. You know, to count the number of pairs AB, where A is between 1 and X, B is between 1 and Y, and you satisfy the equation, A over B is equal to A mod B. Why is my hair so long? Oh god. Okay, closing the window. That is freaking loud. Of course, lawn mowing happens today of all days. My hair is long because I don't cut it. That's it. If you saw the video of the stream, I do go a bit into modular arithmetic. It's university, it's just like people, because it's like, it's not like my house's lawn, it's like, you know, university, maintaining stuff. Alright, so this problem has to do with something I mentioned. If you recall, I mentioned representing x mod m as saying that x is equal to am plus b, where x is like some multiple of m, and then you get like a remainder, right? Because when you divide x by m, what you get is, you get floor x over m as a remainder. Or no, you get floor, like m goes into x, floor x over m times, and then you get remainder x mod m. So x is really representable as x mod m times m, floor x over m times m plus x mod m. And the reason is because, like, this is the remainder, and this is the part without the remainder. So, like, this is only the part that's a multiple of m, and this is the rest. That's sort of where this comes from. But because you can represent a number like this, you can represent x is equal to x mod m times m plus x mod. I'm saying the wrong thing all the time. X is equal to floor x over m times m plus x mod m. Right. So think about this. Now, we're saying floor A over B is equal to A mod B. So suppose this number is equal to like K or something. Then A is equal to K times B plus K. Because A is equal to floor A over B. This is the right equation, right? Yeah, times B plus A mod B. So we let these both be K. A is equal to KB plus B. Or KB plus K. Therefore, A is equal to K plus 1 times B. Yeah, I don't know. I don't know people who like this problem. It's just it's so contrived. They took an equation, they hid it a bit, and then they just told you to figure it out. That's so annoying. I agree that it's detested. So A is equal to K plus 1 times B. And so now we need to count the pairs where that works. So what we can do is note that because K is equal to A mod B, where's my mouse doing? K is equal to A mod B means that K is less than or equal to B because anything mod B is less than or equal to B. Also, K is equal to floor A over B, meaning that what does that imply, actually? Let's think of it a different way. Suppose K is small. In particular, we're thinking about square root decomposition, because think about it this way. If B is large, then A divided by B is going to be small. For example, suppose B is like 10 to the 7th or something. Then A over B is less than or equal to 10 to the 9th over 10 to the 7th, because A is up to 10 to the 9th, which is less than or equal to 10 to the 2. So if B is large, then A over B cannot be that large. In particular, A over B, I think this is a better way to think about it. Ignore K. A over B is less than or equal to 10 to the 9th over B. A mod B is less than or equal to B. So K is also less than 10 to the 9th over B, and it's equal to B. So if B is small enough, then A mod B will be small. If B is large enough, then A divided by B will be small. So what's the largest possible value of K we can have? Well, it would be the value that minimizes. So combining these two, we get K is less than or equal to the minimum of B and 10 to the 9th over B. So if we're trying to maximize this equation, the best value of B would be one that's like sort of closest to these. If you this is just a function you should be familiar with. If you plot this out, if you plot out this minimum function, you can see that it tops out at around B is equal to square root 10 to the 9th. So the point of this is that K cannot be that large because it's only up to, because it can't get larger than the square root. Getting a call from Scam Likely. I think I will not answer that. So B is equal to square root of 10 to the 9th. Yeah, 10 to the 4.5, which is like not that bad. It's like 30,000. So because K is less than or equal to square root of 10 to the 9th, we can just iterate over K. So now we know K plus 1 is equal to X. We have X being a constant. So now we need to find the amount of values where A is equal to X times B. So in particular, B can be equal to 1, 2, 3, 4, etc. And A can be equal to X, 2X, 3X, 4X, etc. We also know that X is the wrong variable to use here, actually. So I'm going to replace that with Z, because X is a different variable. X has a different meaning here. So let's say A is equal to Z, 2Z, 3Z, 4Z, etc. We also have a constraint that A is between 1 and X, and B is between 1 and Y. So this, we only have up to Y possible values of B. And the number of values of A we can have is, what would it be? It would be the largest C such that C times Z is less than or equal to X, which is, by definition, floor X over Z. I should have mentioned that in my definition, but That is another definition of floor. It is the greatest integer that is, wait, k times b plus 1? How? Aren't there two k's? Did I mess that up? So c is equal to x over z. So the answer for, if I didn't mess something up, the answer for a particular k is the minimum of b and, or sorry, it's the minimum of y and the floor of x over z. So this should also be z. And that's it. So we iterate over k, we sum this up. Yeah, you can sleep, totally. Once again, the stream's gonna be available like afterwards. So you can just like you can watch it whenever you want and practice with it and stuff. Oh right, factor the k out. Okay, I forgot about that. I can't do math. Yep. Does this mess with things? I hope it doesn't make it like that more complicated. Yeah, okay. Factor the k out. It's like, I think it's still, this actually kind of makes more sense now. So, I don't even know what I was doing before. Yeah, that makes more sense. What was I saying? We got like b plus 1. No, we'll write a is equal to some z. Wait, hang on. Now I'm confused. A is equal to k times b plus 1. So we're pairing b plus 1 with a. So b plus 1. So this sequence should be 2, 3, 4, and 5, I think. Alright, now this is messing me up. Yeah, I don't even know what I was doing before. So we start from 2. And we get 2k, 3k, 4k. I don't know what z was. I think it almost made sense, but it like doesn't. So the sequence of a is, let me just make sure this is right now. Sequence of a, it should be like 2k, 3k, 4k, etc., right? So it's like the minimum of y floor x over k. That minus 1 because we start at 1. I'm not sure at this point. Now I'm kind of confused, but I'm guessing. Yeah, we'll try it. Sure, why not? So start at x and y, iterate up to like 50,000 or something, just some large value of k. Wait, actually, how do we It should be something that should become, I feel like this is a bit wrong. It should be something that should become 0, like, eventually, right? Oh, wait, okay. There's a bit more we have to do. Because we have to enforce these constraints that, k is also less than or equal to b. We also have the constraint that k is less than or equal to b. Kind of forgot about that. So this can go up to k plus 1. No, k is less than b, so this can only go up to k. Yeah, I see why this is more and more annoying now. So this is more like the minimum of y and k. Why did I choose this problem? I consciously chose this, knowing that I would do this for a reason. But I chose this problem for whatever reason, and I'm sort of regretting it. K is less than or equal to, k is less than b, so k plus 1. No, wait. K is... less than or equal to b minus 1. So k... What? I'm lost. I'm so lost. Does this go up to k plus 2? I'm so lost at this point. Nah, this problem is draining me. And the heat, that too. K is less than b. So k plus 1 is less than b plus 1. I'm just confused. So k plus 1 is less than b plus 1. So what is this bound? So k is less than b plus 2, or k is less than or equal to b plus 1. Okay, yeah, wait. This is the same thing, I think. Or maybe not. No, that's not how this works. Cannot do that like that. Yeah, no, I did this faster during the contest. Now I'm just confused about the details. And I did it in a different way during the contest too. I think this is simpler, because once we figure out this formula, it's just summing it. But I'm just confused about where it ends. K is less than or equal to b. Oh. So, okay, yeah. Alright. I don't know why I'm doing it this way. So k is between 1 and b. No, I'm just... I think I'm being an idiot. I'm trying to bound b plus 1, right? Does b plus 1 have to be bigger than... I'm so lost now. B plus 1 has to be bigger than K. Yeah. So wait, this doesn't make sense at all, does it? Does it now? Jesus. I need to open the window again. It's so hot in here. I'm gonna blame the heat for this struggling, just because heat. So you get 2 is less than or equal to 3, subtract 1, 2 is less than 3, 2 is less than or equal to 2. Yes. I feel like I arrived at the same formula like plus 2 at some point. Don't have respect for this. This is one of my like lowest moments or something. Okay, I just need to like straight up just. So B is greater than or equal to K plus 1. So K plus 1 is greater than or equal to B is less. So B is between this. A is between A and X. A is equal to KB. A is equal to K times B plus 1. So can't tell if this is right. I'm just, is it patience? I'm just lost. I'm just so lost at this point. I'm genuinely just lost. This isn't right, because A has to be a multiple of K. So it's more like K plus 2 is less than or equal to floor A over K. I think I'm thinking about this the wrong way. So K plus 2 is less than or equal to B plus 1 is less than or equal to the minimum of floor. I think it's better to think about it in terms of B. Floor X over K, Y plus 1. Is that it? Yeah, I'm trying to like bound the number of things we're doing. I don't know, I'm just lost. Why do you always catch me in my worst moments? I don't understand you. My God. Is it just the last 2 digits? I mean, it's not the last 2 digits, because, like, you need, like, if you have 3 digits, then it's, like, not valid, right? So you have to make sure that it's not, like, too big, but it's also, like, not too small. I don't know. Because B has to be, like, bigger than the value of K you have. What? Floor A over B is removing. I never thought of it this way. Floor A over B is removing last digit. Yeah. But it's not the last 2 digits. It's like everything is equal to the last. Everything else is equal to the last digit, right? I don't understand. Try what? Like, why'd you use 433? 433 is so big. Okay, yes. So 433 mod 10, right? So in this case, B is 10. So A is 433, B is 10. I don't understand, like, that doesn't work, does it? Because you get 43 is not equal to 3. No, this part is not under mod. This is the only part that's modded. Floor A over B is not modded. $43 is not mod 10. That's not how the equation works. My phone is dying. Sorry, this is problem G. We're still on G. I've just been dying on this. But 43 is not modded. Yeah, no, it's not equivalent mod B. It's only like the right side is modded. Otherwise, that would be maybe less painful. I'm gonna try this and see if it gets it right, because they do have a large case, so let's see. Equals 1, is... Honestly, I'm just gonna try it. Yeah, sure, but like formulas. I'm trying to do formulas. That's what I've been mentioning, that it's easier to think about it like that. If you don't have the ability to grasp observations like that, which I don't, then it's easier to do it this way. And this could still be wrong. I don't know. Y plus 1. It's gotta be like some. I remember formulas like this. Just not exactly sure. Yeah, okay, this works. Sweet. We figured it out, guys. We're so cool. I hope. If it's the wrong answer, I'll be mad. I'm gonna test 4. I got TLE, right? I'm going only up to 50,000. I'm only 50,000 is just because it's bigger than square root 10 to the 9th, which is like 30,000. Sure, but then you like if you ignore, then you have at least 3 digits. Then like you have to like bound stuff. I don't know. Yeah, you always catch me at my worst moments, I swear. It's like actually comedic. I've just been dying on what this condition should be for like the past year, and then I followed my own advice and then it worked. My own advice was just to force it to be an equation, and then I didn't do that, and then it didn't work. And then when I did that, then I could like actually think about it. Break one of the two sets. Oh, you're doing, are you looking at the second last problem? Or wait, which one is this? No, never mind. No, that doesn't make sense. I remember what I did in contest was it had something to do with summing floors. Like my formula, I didn't iterate over K. That's the thing. I did like iterating over B or something, and that had to do with summing floors, and that was annoying because it was like summing. It was just a pain. Are you looking for like you mean like the interval where it works? What's the floor trick that you refer to? Anyway, okay. This problem is so much nicer. I'm glad to be done with that G. I don't know why I torture myself like this. Pin that. I'm gonna figure out the donation thing like after. Alright, you have an array. You want to remove some elements so that you make the GCD larger, if it's possible. So this one's remarkably simple. All you do is, for each number, okay, so say you want like a GCD of x. The number of numbers you can save is the number of numbers that have x as a divisor. Or say, it's fine to not have exactly x. If you have a multiple of x, that's also fine because you just need it to be larger, and a multiple will be larger, so that's fine. So if you want a GCD of x, the answer is the number of multiples of x, or n minus that. Floor trick, yeah. So the answer is the number of multiples of that. So for each number, we just need to count how many numbers are multiple of that. And the other way of saying that is, for each number, for each divisor, increment the count of that divisor by 1. So it's something like, for each number, for each divisor, increment count. That's it. If it's something you made up, what was the 1 second for? Alright, so we just need to quickly factorize numbers. How exactly do we do that? Do you think that do I need to sieve here? Kind of like don't want to. Is it possible to not? Okay, we can prime factorize the numbers. Are people passing this? Okay, whatever. I'll just do it. I'll just do it. So we're gonna write sieve from scratch. Bool prime. And then, so we're gonna store a prime. We're also gonna store a prime factor. It's fine to do long longs. I'm just gonna hit the memory ceiling, whatever. C into n. Okay, so 0. Square root is faster? Really? Should I try it? Wait, the square root, is square root enough to pass? Actually, no. I have to write sieve at some point, so I might as well do it now. Yeah, faster to code. Like, my problem is it genuinely might TLE, because the time limit's 1 second, the numbers are pretty big. I don't know, like, I don't know if that'll work. Like, it probably will, but it's a lot of mods, and that doesn't sound nice. I don't know linear sieve. I'll just do normal sieve. It'll be fine. I is less than... Let's do like... Prime 0 is equal to prime 1 is equal to 0. Like 2 is less than max I plus plus. If prime I prime factor I is equal to I, or allow j is equal to I times I, j is less than max, j plus equals I. The reason we can start from I times I is because we've already considered all of the smaller numbers times this number, because we've already looked at all the smaller numbers. So the only you can start it from 2 times I, and that would make more sense. But you can start it from I times I because you've already considered all the smaller numbers times I. So you're really now only considering I times every number larger than it. Right, so prime j is equal to 0. And we know that a prime factor of j is equal to I. So now, for I equals 0, I is n, I plus plus. I'm not exactly sure the best way of generating factors. I can do DFS, I guess. Cnd AI. I'm gonna screw myself over by using map. So while facts, what am I doing? While AI is greater than 1, plus plus count prime factor of AI. So the count is going to be like, it's like the map of prime factors to counts. You probably could, but I want to write sieve at some point for the purposes of the stream, so I might as well do it now. Actually, I don't... Alright, let me see. I'll look at other submissions of H. Has anyone made square root pass? I guess so. Wait, up to n. Wait, what is this? Huh? Okay, I'm gonna look at someone else's. Talion 8. So, that one sieves. Oh, and the outer for loop for sieve. Yes, but then I don't identify prime factors of large primes. Well, actually, okay. Theoretically, you can say if prime I is that, then if it's prime, then use that as the prime factor. But for convenience, I'm just going to explicitly say that like each prime will just get its prime factor in this loop. I don't think it adds that much of a difference. Most of the work is below square root anyway. What does that trick do? So AI divided by prime factor AI. Also, okay, I need ints. These need to be ints. Int count max plus 10. floor some trick. Interesting. What complexity? Is it like... Actually, yeah, what complexity? I see. I'll read that later, I guess. I don't know. I don't really want to right now. Okay, wait, okay. Do you guys know of a good way to, given a list of prime factors, generate all the divisors of it? I'm guessing you could, like... Actually, yeah, it should be fine. So we're starting with a vector of size 1 with 1 element. So for pair LO x count vector LO. These are like all the elements. So for LOY all for LOI is equal to 0. Wait. For each element, insert itself. I equals 0, I is less than x dot second. No, less than or equal to x dot second. I was thinking of DFS, but I think this is just better. What are you saying? New all dot push back y times equals x dot f, and then all equals new all. Now for LX new all plus count x. Now for each number, let's take the overall GCD. It's fine to start with 0, I think. Because 0 is like the identity. GCD of anything and 0 is itself. Yeah, but if the GCD is 1, then it doesn't change anything anyway. Actually, that might mess it up, because what if we get... Actually, no, it doesn't change anything. Should be fine either way. It is always a multiple of the GCD. Yeah, and it should be like huge. For I is equal to G plus 1. We're checking every GCD higher than this one. And it's equal to min ants n minus count I. So now count stores the number of numbers that are multiples of I. And therefore, the number of numbers that we need to remove are n minus that, or rather, the number of numbers that are not multiples of I. So that's cool. Jesus Christ. What the hell? It's because I have this whole... I had sieve, and then I decided to write it from scratch anyway, because I'm weird like that. So I'm just going to do that. Alright, what's the problem? New all. Wait, did I not declare it? What's the problem? It should be all. Because the new all doesn't exist. Yep. Nope, I pasted in something that I don't know what that is. Multi-tests. Making so many mistakes. And that doesn't even work. And it's not even taking input. What the hell? Did I not read n? I didn't read n. It's 3. Okay. It's a start. We only need primes? Couldn't primes be like less than the GCD though? And then that's bad? You could take Steve out of solve. I don't think it matters now. Because I'm only running it once every time. Right, okay. What's the problem? Oh. One, 1, 2, 1, 2, 4. Yeah. What? It goes min ants n minus count I. Right, so what did I mess up here? Am I computing the GCD wrong? Max is huge. Count is like big. What am I doing? G is 1. Count 2 is 0. Now I'm confused. If I divide the array by it doesn't make it like it will work, but it doesn't make a difference because if the GCD is 1, then it doesn't change anything anyway. Well, okay, fine, do it. Show me wrong. Are you saying that you only need primes? Like, what if you have, like... Can I come up with a counter case? Like, what if you have... Every number is divisible by 5. Then, like, one number is... divisible by 2 and 3 and 5. Or a bunch of numbers have that. Like the new GCD is 6, for example. And maybe you have a bunch of like multiples of 6, but they're all relatively coprime except for the 6 part. What's wrong with G plus 1? You're literally just checking every single GCD that's greater. How is that wrong? Somehow my implementation is being screwed up. I think I used the wrong count. That's why. I'm shadowing count. Oh, don't I have a compiler flag to? Oh no, I got rid of that. I kind of actually want to add that back. Let me add yeah, let me add that back. Shadowing is kind of important, huh? Because the problem was that I was adding to this map, and that doesn't make sense. Oh, for Christ. Okay. Count. I'll do that. No. Oh my god. This is so dumb. Why am I doing this? Why am I doing this to myself, huh? Swear to God. This Mac is driving me crazy. Still 0. How? What am I messing up here? Look at some prime P. GCD will be multiplied by at least 1 prime. So therefore, we just need to find the minimum number of elements to add a new prime. Sure. Okay, I guess you can do that too. Alright, that makes sense. But that doesn't mean that this should be wrong. erase everything in code again. I'm literally like, it's like a single thing off. I've already come this far. Like, is this wrong though? That's the thing. Is it wrong? Oh wait. It's because I never actually fixed it. So it wasn't actually compiling, that's why. There we go. Finally. That doesn't make sense. I just pasted the input instead of compiling. I see what you mean, but that's fine. Should be fine, I think. Maybe I'll get TLE and eat it, but whatever. If I get TLE, that is okay. Yeah, there we go. Okay. Alright, now let me see. Is there anything I can like actually do about this, or do I actually have to do the other thing? I don't know, it's I'm just being weird. Okay. I've solved this before. I feel like I've done like something like this before. How did I do my old solution? I'm kind of interested in that. How did I do this before? I just straight up square root factorized it, I think. Oh wait, no, I factorized it. Oh no, I did that, okay. Yeah, alright, fine. There we go. You guys happy? No, actually, this doesn't make sense. Hang on. I think I prime factorized it instead of divisorizing it. I think that was what I did before. I prime factorized it using square root, which is like a log factor faster, and I guess that's enough. Okay, now what have I done wrong? We're counting primes. Okay. It's not a thing that every number has that exact thing. Oh wait, duh. Okay, I guess I do have to divide everything by that. Alright. I will submit to that solution. I did not expect the divisor finding the TL either. That's kind of annoying. Sure. Okay, that problem's over. That's still close. Why is that? That's still close. That is odd. I guess the sieve does that? I don't know. I mean, there's linear sieve and stuff like that. I'm not sure if that runs faster in practice, but there is a linear version of sieve. So I guess that's something you can do. You could get rid of the map, but I don't see how that helps. Does it help? How much does it help, actually? Maybe that makes a difference. I don't know. I don't really want to spend more time constant optimizing that, then. Yeah, you probably could get rid of the map, but, like... I don't know. I think the main problem would be, for each number, find its divisors. It was just to get the unique prime factors. You don't need the map, though. It used to be for the divisor part. But you don't need the counts anymore. You just need the unique one. So it is fine to get rid of the map. Alright, in terms of the intent for this one, this was the only problem I had that had Chinese remainder theorem, and it didn't even like have the calculation. So if you want Chinese remainder theorem, let me see. Should be something here, right? No? Really? No, Yosipu? Okay. I guess not. Well, I mean, there should be some template thing to have Chinese remainder theorem. We can probably test it somewhere. I'm sure I kind of want to find that now. Actually, here. Chinese remainder theorem, for whatever reason, is a tag on code forces. So if you want to practice that more, there you go. Yeah, I have Mac. Are there questions I missed? If so, please re-ask them. Do I recommend CSES? Yeah, it's pretty good. The lack of editorials could be painful, though, because there's no, like, progression or stuff like that. It's different in used to go training because there is progression. But in here, it's like, there's, like, progression within each separate part. I do have sieve in my template. It doesn't do prime factors, though. It just, like, does is prime or not. So in this part, you have two integers, x and k. You have to find the value x mod k. There are n ancient numbers, c1 to cn, and you have to tell, and you can get all the values x mod ci if you want. You're given k, you want to find out if, given the values of x mod ci, you can deduce x mod k for any positive integer x. So, in particular, like, given, for any number x, given the values of x mod, like all of these array values, can you determine x mod k? Right. Okay. So the reason this has to do with Chinese remainder theorem is because it says that if x and y are coprime, then there's a unique remainder of z modulo x times y, where z mod x is equal to a, and z mod y is equal to b for any a, b. If x and y are not coprime, it gets a bit more complicated, but I think it essentially boils down to, because we know that x exists, then it's fine to say that there will still be a number that like satisfies it. But if like the GCD of x and y is equal to g, and I think it gives you it would give you a z mod like the LCM of x and y. So really, the power you have to determine depends on the LCM of all the numbers of C. So, yeah, so like, essentially, with these remainders, you can determine any number modulo LCM XM. I think it is unique. It should be unique, because otherwise this problem doesn't work. It should be unique if it exists. Now it's very possible that it doesn't exist. For example, the example I gave, z mod 4 equals 1, z mod 6 is equal to 0. There's just no number that works for this. But if it does exist, I think there should be a unique z mod LCM of x and y. That should be implied by the theorem. Because like, say you have like z mod x is equal to a, z mod y is equal to b. Now, for this to exist, it is required that a is equal to b mod GCD of x and y. Otherwise, you get a situation like this. So if a is equal to b mod GCD of x and y, then you can essentially divide everything by this GCD and not have problems. So what I mean is, like, if a equals 1 mod GCD of x and y, and b is also equal to 1 mod GCD of x and y, then you can essentially say, I'm trying to think about how best to explain this. You can subtract 1 from a and b, and then divide everything by this g. Solve for z over g, multiply it back, and then add back the original value of j, and that gives you z. I believe that would work. Let me think about that for a second. Does it actually work? Because that doesn't equal the LCM. It should be like xy divided by g. Alright, okay, yeah. So solving this will give you a unique z mod xy over g squared. And then when you introduce the value of a mod the GCD back, if you introduce the value of a mod g, then that part determines an extra like equivalence class of like g values, kind of. So like there are g possible values of a mod g, and there are xy over g squared unique possible values of z. And so each of these has g possible unique values from the residue of a. And therefore overall you get xy over g unique values of z, which is the LCM. It's kind of like a makeshift proof, I guess. kind of sketchy, but I think that's where it comes from. So you get a unique z modulo the LCM of x and y, and if you have many numbers, then you get a unique z modulo those numbers. So it's sort of like, it's like a corollary of the theorem, I guess. Although I'm not, maybe the theorem mentioned this, I'm not exactly sure, but this is just the follow-up of that. So the answer is yes, I'm pretty sure. So now what we do is, well, we can find the LCM of all of these values. And now the question is, can we use it to determine the value mod k? Now, if k is a divisor of the LCM, then we get a unique value modulo this LCM. And then from there, because k divides this, like, how do I explain that? It should be like intuitive that this works, right? Like if k is a divisor of the LCM, then getting a unique value that modulo the LCM will give us the exact value we need mod k. Yeah. To explain it in Chinese. Oh god, that would kill me. Should I learn Chinese to explain this theorem then? Okay, now I'm confused again about why this works. But like, if k divides the LCM, that's the condition we need to check. Alright, because if k divides the LCM, then I don't know why I'm confused about this now, because I like figured this out myself, but I am. If k divides the LCM, then we have an answer. Because using the Chinese Amanda theorem, you can determine x mod the LCM. And therefore, taking that mod k, because the LCM is a multiple, it should just work. I mean, yeah, like it'll just be accurate. Because x mod a multiple mod k is equivalent to just x mod k. If you think about it like subtractions, if you think about mod like a bunch of subtractions, I guess that makes sense. Because you're really just subtracting, yeah. You're just subtracting multiples of k. I don't know why it took me so long to wrap my head around that. I'm going crazy. So the condition to check is if k divides the LCM. If k does not divide the LCM, then you cannot get the answer. Because, for example, say you have like k equals 2, LCM is equal to 3. So 0 mod 3, 3 is equal to 0. Mod 2 is equal to 0. 1, 2, mod 3 is equal to 0, 1, 2. Mod 2 is equal to 1 is equal to 0. So these examples don't make sense. Okay. 4, say you have, for example, 4 mod 3 is equal to 1, mod 2 is equal to 1. But 4 mod 2 is not equal to 1, so that doesn't work, because 3 is not a multiple of 2. If 3 was a multiple of 2, it would work, because then we're only messing with multiples of 2. So really, this is the condition. The problem asks us to check if k divides the LCM of all the numbers. So how do we check that? One way to do it, we look at every single prime factor individually. And we ask, like for example, for some p, say that k is equal to p to the a times whatever. And LCM is equal to p to the b times whatever. B is equal to the maximum power of like B is like the maximum power of P over all values of C. That's sort of a way to think of LCM. So we just need the maximum to be greater than A. Another way to define that is we say that the minimum of B and A is equal to A. And that's kind of convenient because then it means we don't need to store values greater than B. We simply need to store the minimum of B and A. So when we encounter a new P of X, essentially we can say that like if X is greater than, okay, wait. I'm trying to justify the approach that I'm thinking of. The solution is kind of like OP. It's kind of like magic, but I'm trying to justify it. I guess I should explain the solution first, I guess. Basically, the solution is for each CI, set, take like L equals the LCM. Set L is equal to LCM of L and CI. And then set L to the GCD of L and CI. This way it doesn't overflow because at every point L is at most K. Except for here, but then it's at most K times CI and CI is up to 1,000,000 so it doesn't overflow. So for each CI, do this. And so the way I'm trying to justify this is like, every time you get a new prime factor, you're essentially saying B is equal to maximum of B and X, and that makes sense. And then you're saying B is equal to the minimum of B and A. So doing this is equivalent to doing this for each prime factor. And that's nice because like at every point we're going to maintain the minimum of B and A. If the minimum of B and A increases, then this value B will increase. And if it's already hit A, then there's no reason it would increase more because A is going to drag it down every single time. So this does this simultaneously for every single prime factor. And that means it works. Because we're just asking for each prime factor, is the minimum of that prime factor in the LCM and the prime factor in the GCD equal to the prime factor in the GCD, which is equivalent to saying, is B greater than or equal to A? It's like the main idea for this problem is that B greater than or equal to A is equivalent to the minimum of B and A is equal to A. And if you think about GCDs and LCMs like prime powers and stuff like that, then this solution kind of works. I feel like I'm losing people here with this. I'm kind of losing myself. I'm just trying to explain why this code sort of comes into play here. Because all we're trying to do, we're trying to find if the LCM is a multiple of K. Sorry, actually, this should not be CI. This should be, it makes more sense if I actually use the right variable. This should be the GCD of L and K. I'm always tired. That's never gonna leave me. I'm not tired because of YouTube, I'm tired because of my lifestyle. That's the thing. Alright, so How exactly do we do LCMs? LCMs can start at 1, right? Yeah. So Cn to n to k. Why are you capitalized? Jesus. Code for these problems is generally remarkably simple. Which is kind of odd. Because the theory behind them is such a pain. I mean, the code works. That's not what I have to do. Alright, about a 1 in 8 chance of success so far. I'll take that. So yeah, like logic. There was not much logic in that explanation, but there was some stuff. Okay, so that leaves some number of problems. We gotta catch up to this guy. So this is like, I'm gonna take a rest midstream. I have to finish this at least. You have an array. I'm probably not gonna do a topic stream for like a week or something. I don't know. You have an array with n integers all between 1 and m. For all x between 1 and m. Wait, okay. Everwill, are you saying if it exists, then it should be unique, right? That's what I've been thinking about for the last problem. If it exists, it should be unique, but there's a chance that it doesn't exist, and that's the problem with it. Like, if you know it exists, then that should be fine, because that's the basis of the previous problem. Okay, good. Otherwise, it's made a fool of myself again over like the past 20 minutes. I did not do ICPC World Finals because I have not like. Yeah, it's given it exists here. I did not do ICPC World Finals because it's my first year in college, so I can't have done that yet. Coprimality is nice, but that almost like it does. In the worst cases, it doesn't happen, and then you're just like left without having fun. I might do World Finals. I don't know. Like my problem is I've given this rant probably on stream before. I don't know who my team is. We're not hosting tryouts until like February. It's like a month before regionals. So it's gonna be hard to practice and figure out how we work together and stuff like that. Alright, you have an array with n integers, all between 1 and m. This is my problem. Or I took an edu problem. The original problem was do this only for 1, and because I went over it in the stream, I just made it, or in the previous video, I just made it like count for all x equals I. So actually, I don't need to do this on stream. If you watch the video, you'll see the exact solution to this problem. So I don't need to go over it again. But if you do have questions about that solution, you can ask me right here. So I'm just going to implement what I talked about before. So plus count AI. I do need mod. Do have a template for modular arithmetic as well. Mod op. There we go. If you will open, thank you. No, I want to solve it so I can like have that clean like 15 out of 15, you know? I don't know if you know, but I know. I'm using the exact same variable twice. Count J. So G being the definition of that statement, by the statement is mpow 2 to the tote minus 1. We go backwards now. F5 is equal to GI, for J is equal to 2 times I, J is also equal to M, J plus equals I, F5 is equal to Fi minus Fj plus mod. So there we go. If you're confused about that, just watch the video. It'll make sense, probably. Hopefully. You have weekly tryouts? Wow, that sounds like a pain. Wait, like, so do you get like a running rating system or something, and the people who have the best just win? Kind of wish I had something like that. That'd be better than just waiting for like. I heard the way we do it, it's like a single contest, and it's like over multiple days. So I don't understand. Why would they do it over multiple days? That doesn't make any sense. Those are the rumors that I've heard. So I don't know. Okay, this one's like a problem. So you have n integers. For each AI, find its 2 divisors such that the GCD is 1. Sure, less randomness, but like, I mean, if you hosted many contests that fit the format, like that make more sense and fit the format, then like, isn't that better? I guess you need a lot more problems that way if you're doing it weekly, but still. And also, you get practice. I just don't. I have to self-regulate. I can't even practice individually with my team because I don't know who they are. Alright, you're given n integers. For each AI, find its 2 divisors such that the GCD of 2 divisors is 1. Yes, that sort of thing. Essentially, you can take its prime divisors, you can take the unique prime divisors, partition them into 2 like sets, and then those sets will not intersect. And the reason is because like mod. Like for example, let x is equal to, I'm not sure if you need all the powers, but like something. Let x is equal to p1. I'm gonna ignore the exponents because whatever. If you factor the exponents in, it doesn't really change much. So let x equals p1, p2, p3, p4. Let d1. So basically you can partition this however you want. You can give like 2 of these to the first and 2 of these to the second. I think you need to give, I'm not sure. You probably need to give all of them. All of the primes must be part of at least 1. Otherwise you can have, for example, like if you have 2 times 3 times 5, if d1 is equal to 2 and d2 is equal to 3, then you get this accidental overlap. So you don't really want that. So D1, for example, is equal to P1, P2. D2 is equal to P3, P4. So D1 plus D2. The GCD would be greater, if the GCD is greater than 1, then it is a multiple of at least one of these primes, as you guys have told me in H repeatedly. And I forgot to update the problem, so let's do that. For this one? Wait, you don't need to... Did you read... Wait, what problem are you solving? Wait, are you still talking about J? What Mobius inversion here? You don't need to count, you just need to find any two. Yeah, J, it's just like pretty much Mobius. So like, how does this work? So really we're interested in, for any of these primes, does D1 plus D2 divide P1? Or does it divide P2 or P3 or P4? Well, in this case, P1 and P2 are equivalent to each other because they're both in the same number. So are P3 and P4. And P1 and P3 are both like... Actually, I'll make it like 5. I don't know, for whatever reason. So let's ask, is D1 plus D2 divisible by P1? So D1 mod P1 is equal to 0 because it has P1 as a divisor. And what about D2? D2, because these are primes, D2 does not have P1 as a divisor. So D2 mod P1 is not equal to 0. And therefore, we get 0 plus something that's not 0, so we can't get 0. So therefore, D1 plus D2 mod P1 is not equal to 0, and therefore it's not divisible. You can do this proof for like every single prime and it works. The point is, you just have to make sure that like every prime is part of one of the divisors. Otherwise, this proof like for example, if P3 wasn't here, then this proof just doesn't work for P3. It might just be wrong. So you have to give a prime to like every single one. Other than that, it's like the exact same factorization code as H. So I would just copy that in. There we go. Except this time it's only 10 to the 7th. C into AI. Alright, so now what I'm going to do is, first is going to be the first prime we encounter. Every instance of first, we will put it into the first number, and everything else will just go into the rest. And that should work. So while PF AI is greater than 1, if first is equal to -1, or PF AI is equal to first, then cur times equals that, else we give it to rest. So we get rid of that factor, now we do that. Okay, now if it's invalid, then we will not have given anything to the rest. So this only doesn't work when you have only one prime factor, when it's a prime power. And in that case, like every divisor is going to be divisible by that prime power, I'm pretty sure. since they all have to be greater than 1. So that just doesn't work. The connection, what? My phone disconnected. Okay. Wait, am I missing chat? No, okay. Good, because my phone froze, so I just wanted to make sure. So if rest is 1, that means we only have a prime power. And otherwise, we have at least 2 prime factors, and therefore everything works. So, if rest is equal to 1, invalid. I guess I can comment that. It's like a prime power of a single prime. And then add that to B. Else, A dot pushback cur, B dot pushback rest. Actually, wait. I don't think I actually need to print these on a different line. Because it should just it should just use the normal comparator, and the normal comparator ignores spaces, and it ignores new lines. So just to confuse myself, I'm going to print it like this. You're welcome. Segfault, okay. Why? What's up with that? Well, AI is greater than 1, I guess. That doesn't make sense. I shouldn't change anything. Right, okay, where's the segfault at? We're not doing multi-tests. We're reading in N. Oh, that's fine. Yep. Because I'm shadowing again. Love that. X, Y, X, Y. I need to rename these because my variable names are stupid. That should work. No, it does not work. Because I need to set first. Smallest number that can be expressed as the sum of 2 different cubes in 2 different ways. Like 2 different, I'm gonna guess it doesn't exist. Let's see. Jump from 2 to 31. So yeah, printing in this stupid format does work. I can make them hate me for it. Okay, anyway, this is probably gonna pass. So, alright, congruence equation. This is kind of the one I was scared of, to be honest. I've not solved this one, but I picked it because it was like very equation-y. Which means it's actually like terrible for me right now, but it's kind of like what I'm thinking. You know, terrible. So you want, let's write this out. You want n between 1 and x. You want n times a to the n is equal to b mod p. Equivalent to b mod p. I don't care. Sure, I'll write the triple equals. It's equivalent to b mod p. So you're given a, b, and p. P is up to 10 to the 6th plus 3, which means it's like not that big. And then x is like x is up to 10 to the 12th, which is harder. Anyway, what's the answer to the cubes thing? Does it exist? I feel like it's kind of hard to... Or maybe it could just be like massive. Like some massive number. I'm guessing it's either it doesn't exist or it's like beyond comprehensively massive. Alright, well this sample is annoying. These samples don't say anything. Okay, so we get n times a to the n mod b equals p. Or equals b mod p. So I'm guessing the thing to fix is a to the n. Oh. So a to the n mod p will be cyclic. We'll get 1a, a squared, and then eventually we circle back to 1. The cycle does not necessarily have to divide p. I believe it divides the totient of p, in this case, which is p minus 1. So the length of this cycle is some divisor of p minus 1, but I don't think that matters that much. So what do we do with this cycle? Well, we can find out the length of the cycle. Let the length of the cycle be L. Again, I'm starting at 1, I'm multiplying by a until we get 1 again. It sort of forms a cycle of the values of a to the n. Why is the... It is similar to Fermat's little theorem. A to the... At some point, a to the n is 1, and that is related. Oh wait, actually, wait, no, the period should just be, wait, hang on. I don't think that's guaranteed, though. Wait. Is the period always the length of the... I don't see, like, why that would be true. I remember, like, thinking deeply about this stuff, and I've forgotten it. 1, 3, 4... Yeah, no, it isn't p. It isn't necessarily p minus 1, right? I'm thinking about my proof of Fermat's little theorem now. I think I screwed it up. I don't know. Oh wait, no, never mind. I was thinking of something different entirely. So this is fine. Yeah, okay, never mind. I was confused about something that doesn't matter. Alright, so L is the length of the cycle. We know that L divides p minus 1. I don't think it matters that much. But, it's like a thing here is that if we fix a to the n mod p, then we will have that n is equal to some multiple of L, some like value c times L plus something like k, where k is fixed. So the values of n that work are k, k plus L, etc. And so we need to find the number of values where this works. Yeah, no, I was confused about like the period of Ka and the period of a to the k, but Ka is totally different. Because I was thinking about I was mixing up proofs in my head. That's what was happening. So yeah, it makes sense that it's not necessarily p minus 1. Like the length is not necessarily that. So we'll get k and then k minus l, etc. up until we get 0 and then k again. All of these numbers are unique, I'm pretty sure. That is something that I've sort of proven before. Like basically if they weren't unique, then you have AK is equal to BK, and then A is equal to B, but A and B are between the mod, so that can't really happen. So these are unique. I'm only like, what I'm doing is I'm fixing a to the n mod p, and then like, I mean it has to be that, doesn't it? Because it's like every value in the cycle is different, because otherwise the cycle would be shorter. And so every time you go around the cycle once, you get the same value. So the only values where it's possible are things with remainder k modulo L. Multiplying by n? No, but it's powers of A, so A is static. I'm ignoring this part. I'm just fixing a to the n right now. I'm just saying a to the n mod p is equal to something. And then from here, now we're working with these values, and we're going to see which of these values are going to satisfy the rest of it. So the value that does satisfy the rest of it, we can find with modular inverse, because it's like, now here we get, so we want CL plus K is equal to CL plus K times, let's say this is, I don't know, E for exponent. That doesn't make sense. But CL to the K times E is equal to B, is congruent to B. We want to solve for C. So let's see. How exactly does this work? Is E, well, P is prime, so everything works, sure. So CL is congruent to B over E minus K, and then C is equal to that divided by L. So then the first time where this happens is C, and then every like L times, etc., then this will work. And so we just need to count how many, it's loud, huh? So we just need to count how many C between, like how many, whatever this is. I'm sure you know what I mean. Like how many of these numbers are between 0 and x? So hang on. So no, it's not necessarily L. I think I'm a bit wrong here. It's not adding L each time. It's well, let's see. So a bit trippy, I guess. So n is equal to CL plus K. We've solved for C here. So it's CL plus K. CL plus K plus the period of this, which is P, times the period of this, which is L. So this should be plus LP, something like that. And then CL plus K plus 2LP, etc. Yeah, sure. See ya. Hope we got something out of it. I didn't get to the hard ones yet, but I will, like, soon after this. I think XSUM is pretty interesting. So CL plus K plus LP, CL plus K plus 2LP, etc. So we just need to find how many of these works. And this should be equal to the floor of x minus CL plus K over 2LP. If CL plus K is 0, we ignore it. Well, actually, we can try n equals... I think this solves for n between 0 and x. So we can try 0 explicitly and see if that works. Actually, 0 cannot work, so we're fine. Yeah, 0 doesn't make sense. C can't be 0. Seems good. Who's still watching, by the way? Who's here? At this point, I'm just doing this for the video archive, because some people did want to do the harder problems. Anyway, this is the final equation. So we sum this overall, and at some point it was down to 4 viewers, which is kind of interesting. Alright, let's just read stuff in. Does this solve for 0? I mean, it shouldn't, right? Joint streams? On what? Okay, so for each exponent is equal to 1 while I'm going to try and be consistent here. So k is equal to 0. V is equal to v times a mod p plus k. So this should be E. You stream except you can bully me on stream. Oh god. That sounds fun for only one of us. Anyway, is there any glaring mistakes that I made so far here? I think it seems reasonable. So what we need to do is we need to find C. Mod up again. Is there CRT here? Wait, why? Where is it required? Mod is equal to P. I need the cycle length. Oh, I think I'm okay. I think I'm doing CRT, but like manually, where I'm doing the modular inverse myself. I didn't reduce it to CRT. I'm just kind of like bashing it in an equivalent way. That might be. I think that might be what's happening. I do have modular inverse. Like there are a bunch of divisions happening here. Like I'm specifically asking for this congruence. So we might be doing the same thing, but I'm not sure. Maybe not. Let's make this continue to L on P. I can pre-compute that, but whatever. So I wouldn't call it genius. It's probably overcomplicating. That's not necessarily a good thing. So this is the value C. Then CLK is equal to C times what? Times L plus K. This doesn't need to be mod P. And then ants plus equals X minus CLK over 2 times L times P. No, wait, this should not be 2. I don't know where that 2 came from. That's really dumb. Don't do that. Just YOLO, see if it works. I doubt it, because, you know, code, but yeah. Zero. Awesome. Okay, so let's figure out what happened here. So 2, 3, 5, 8. I'm also having concerns about the number 0. So this could potentially be off by 1 if 0 is a thing. But I hope not. Wait. Does this actually make sense? CL plus K. L and P are definitely coprime. That is a guarantee. Do they have any sample explanations? N equals 2 and N equals 8. Oh, I guess they, yeah, just give you what works. 2 times 3 squared, 9, 18, mod, 5, 8. Yep. So in this case, this is E equals 2. So yeah, E. So I'm interested in E equals 2. Or E equals 9 mod 5, which is 4, yes. So 4 in CLK is 2. What is... Wait, should it be P? Should, right? Wait. I'm messing something up. I think it should be... Yeah, it's not right. It is like almost... But it's like... It should be +1. +1, but at the same time... If this is less than 0, because floor is kind of a pain... Actually, I can do it this way. Plus L times P. The problem is the floor rounds towards 0, which is a pain. I pasted in the formula. Floor rounds towards 0, which gives me problems. So I think that is exactly what I want. 1. Does it pass samples? Jesus, that's a lot of numbers. Indeed it does. It passes samples. Let's try it. How do we drop to 4 viewers and get back to 20? I don't understand this, like, stuff. Alright. Alright, looks right. Hopefully. Wouldn't pass 31 tests and still be wrong, could it? There we go. That's a lot of time being used. Okay. Anyway, yeah. So like I said, probably one of the most important things if you're struggling to grasp a problem, just write it down as a formula. And then mess with that formula, and then do some stuff, and write everything down as a formula. And then you can combine these formulas in something like this. And even if you're manually deriving Chinese remainder theorem for whatever reason, it still works because you did the formula stuff. And that's great. Formulas are great. Okay. Wait, is the answer big? Is there a case where the answer is big? There should be, right? Like if you have small p, huge x, yeah. They just didn't give that as a sample because they hate us. Yeah, p is massive. That's not helpful. Yes, this live will be archived. It'll be just on my channel, and it'll be in this playlist that you can find right in the description. So either way, you can find it. Okay. Oh, I didn't update the... Damn it. Now it's going to be hard to make timestamps. Okay. Well, now we're doing M, so I forgot to change that. Awesome. The worst I had was I didn't want to put like a super hard one this time. But yeah, the hardest one is a 2500 this time. Do you call XSum easy though? I would not call that easy. Anyway, now you can see the line of green. I just have 3 left to do. This one's not bad, this one sucks, this one's like difficult. I don't know why I added the second last one actually. It's kind of a pain. Is my voice soothing? I'm not sure what my... I know there are like certain classes of streamers that like... There are certain classes of voices that work for different purpose streams. I'm not sure what mine falls into. Because I can do like the monotonicity. Prove that... Yeah, no, I'm not. Thanks. I don't even know what that word means. Thank you very much. How do you convolve a series? What is a convolution in that sense? I don't even know. Okay, this one's like another, it's another Mobius one. So imagine like you like... Sorry, I don't know how to help him. That is my problem. So imagine like there's... Okay, so... Read the problem. You wanna find the number of subsets that sum to less than or equal to m and have a GCD of 1. I think. Yeah, you want to you want to yeah, Jesus. Yeah, it seems like it could escalate pretty quickly. So you want to figure out I'm gonna find the number of subsets, which is like, I don't think it'll be 3,000. I think it's like, this is like an upper bound. That's probably less than this, because the viewers have been low for a long time now. I think this topic is generally just not that like popular. So you want to find the number of subsets where the sum of AI is less than or equal to m, and like the GCD is 1. But let's ignore the GCD condition for a second, and then we'll turn it into like a solution. So just number of subsets less than or equal to m. But this is like, it's just knapsack. I mean, you have 50 elements, it's knapsack. That part should not be hard. If you don't know what knapsack is, check my DP stream. But we're doing 2200s now. So essentially knapsack to find the number of subsets with sum less than or equal to m. That will take what would it be? It would be O of nm. But remember what we just did from like problem J. Essentially, we find a function g of I, which is answer for the GCD being a for the GCD being a multiple of I. Oh yeah, the mod has changed. It is not FFT though. That is not what the solution is. So the g of I is the answer for I dividing the GCD. How do we compute that? Essentially, we do the knapsack. We do the knapsack, but only with the elements that are multiples of I, including I itself. And that way, we're guaranteed that everything is a multiple of I, and therefore the GCD has to be a multiple of I. Now this is O of nm over I. So the total complexity that we would do if we do this strategy is sum of nm over I, which is I equals 0, I equals 1, m. What? How'd that happen? Which is n times the sum from I equals 0, m of m over I. And I said in the video, that is equal to nm log m. So this is equal to m log m. So this complexity is like fine. So we do that, and then similar to problem whatever it was, the one with the coprime sequences, we know that we want f of I is the answer for GCD is being exactly I. So let m be like 10, for example. So we know that g of 3 is equal to f of 3 plus f of 6 plus f of 9. So we can rearrange it. I've already gone over this solution. I don't know why I'm doing it again. But we can rearrange it so that f of 3 is equal to g of 3 minus f of 6 minus f of 9. And therefore, all we need to know is the f values of the larger multiples. And when we get something like f of 6, it has no multiples, so f of 6 is just g of 6. And so for the larger ones, we immediately know the answer, and we go from largest to smallest, and we figure out the answer that way. So it's like the exact same as the other problem, except g is just computed differently. So nm log m, it passes generally well. And this is the div 2f, by the way. It's rated 2200. It was easier than the E. Or it was a div 2e and it was easier than the D, I think. I don't remember. There were like 4 or 5 or 6 problems. Oh yeah, wait, I forgot. It's like the knapsack is slightly weird because you get like the number can be anything in that range. But really you just like you can just like do DP with prefix sums. DP of I. And that should work fine. So for equals 0. We're going to compute f 100,005, g 100,005. Why do some studies use different mod values? Because this mod works with NTT, and 10 to the 9th plus 7 doesn't. Or this mod is easy to work with NTT, which is like integer FFT, I guess. And the other mod, 10 to the 9th plus 7 is, I'm not sure exactly how it works, but I think it's a pain at the very least. But now, the way it used to happen is that now, whenever you saw that mod, you could figure that it was an FFT problem. So they started using it in problems that weren't FFT problems, so you couldn't immediately tell. Like now, this is not an FFT problem, but it still uses that mod, so it's kind of disguising. So that's why it's everywhere. If we just got rid of 10 to the 9 plus 7 overall, then this would be easier. But 10 to the 9th plus 7 is like beautiful, so we should not get rid of it. Anyway, this problem has nice samples. Do appreciate that. So let's go. I equals 1. I is less than or equal to m. I plus plus. Do stuff. Let's just finish off the rest. I is equal to m. I is greater than 0. I minus minus. And j is equal to 2 times I. J is less than or equal to m. J plus equals I. F of I is equal to f of I minus f of j plus mod f of I is equal to g. I don't even need g actually. I'll do it for clarity. You don't need g. You can implement it without it, but I'll do it just for like to match the writing I've done. See out f of 1. Similarly here, you could also like compute it for all m from 1 to m, but that sort of gives it away, so you don't really need to do that. That sound is kind of annoying, huh? I'm gonna close the window again. As soon as I close the window, they're gonna go away. So that's awesome. I do know convex hull. Actually, no, I don't. I'm aware of how it works. Some like stack thing. I don't actually like. I can't code the algorithm from scratch. Yeah, but I tried apps and they screwed with the rest of my sound, so I just don't want to mess with it. Because remember that like time where my sound just sucked for a long period? I just don't want that to happen again. Alright, so we're going to scale all these intervals down by I. Yeah, I don't really want to filter myself. That's funny. Alright, so suppose we have this interval L, R. We want to find like, suppose like the blue markings are multiples of I. We want to find the nearest multiple of I for L and for R. So for L, it's ceiling. Seal. It's I times the ceiling of L over I, and Ri is equal to the floor, because we should go down, times floor R over I. I'm doing this for myself because I don't want to screw this up myself. Yeah, this could be Mobius inversion. Like you can, like as soon as you have the G values, you can do like whatever algorithm you prefer with it. Fingernail is killing me. Okay. So CVI is equal to ov, no, this should be j dot first is equal to ovj dot first plus I minus 1 over I, ceiling, vj dot second is equal to ovj dot second over I. G of I is equal to compute I. Do knapsack now. For like 0 is 9. Alright, so dp 0, 0 equals 0, 1. 4. I'm gonna do some dp and keep some like running prefix sums. Yes, I've done Mocha and stars. Explanation is just like literally the exact same thing as the j, except you compute g of I differently. And you figure out the intervals and stuff like that. Code Chef Snap. When does that start? I've heard a lot about that. I don't think I heavily doubt I can make Final Zone. I think that's the only way I can win a prize from it. This should be equals m. If so, we should include L. So if let's see, if tot, no wait, sorry. If j is greater than or equal to L, then we should include the L here. Tot is equal to tot plus dpi j minus L mod dpi j is equal to tot. So we're like keeping a running prefix sum over the interval LR. And then now that we're done with this R, we can get rid of it if it exists. I sort of skimmed over the DP part, but like it's just we keep a running prefix sum. We include L when it exists. We remove R when we're done with it. It's just indexing from there. That should work. Does not work. Okay. Because it should be I plus 1. One. Not much better. Because this doesn't even make sense. What is L? What is R? L is equal to CV I dot F, R is equal to CV I dot S. Surprised I even got one. Now we're printing negative something. Negative something negative. How are you negative? How is this possibly negative? I'm opening the wrong thing. God, I did not mean to open that. Thank you for opening. Goodbye now. What am I missing? Okay, let's try actually like the small sample. So this is -1. Let's see. So these initial values are right, and the problem is the other one. So that's totally wrong. Right? Why are you so small? Why is 1 0? Oh wait, this should be m over I, that's why. There we go. Yep, because we're trying to get to the best we can do is m over I. There we go. We're good. Because the highest number we can get that's less than or equal to m is the floor of m over I, because it's also the definition of floor. That comes up so often. Looks like we're doing well. All right. 2 to go. And I'll be done with this stream. How awesome does that sound? I don't even have to miss my class that isn't happening. How cool is that? And for those of you that are still here, have you heard? Actually, never mind. Oh yeah, I'm gonna stream it soon. Okay, listen. Look, to be honest, these last two problems are like only this is 2400, this is 2500. Only if you're like really into this stuff should you try this. If not, I think Omnic Stream is a better thing to watch. So I'm going to finish this because I want to complete the problem set. But you guys can feel free to just watch this because it's probably going to be more valuable than watching these last two problems. So do what you want. Alright, so in this case, we have distinct prime numbers. We want to find the kth smallest integer such that all of its prime divisors are in this set. All right, kind of forgot how to do this. I know it's n is 16, which is a bit too much. If we did binary search, we could theoretically do some stuff. The problem is, all of its prime divisors are in this set. How exactly do we do this? Yeah, sure, go ahead. Essentially, you have a number k, you have a bunch of prime divisors, you want to find the kth number where all of its prime divisors are those. It has no other prime divisors. Not exactly sure. Kind of forgot how this works, to be honest. But let's see. So you get a set of n distinct prime numbers alongside with a simple task. So generating the numbers is kind of a pain. Suppose we do binary search. When we do binary search, I'm gonna reopen the window now. I need to get out of the heat. I might do the last problem first because I know how to do it. But remember this was a pain. Small n just worse and stuff. Yeah, I totally forgot how to do this. I mean, I've solved this before. Like I haven't accepted submission to this. I just forgot how this works. So can't necessarily like generate stuff. Can we? It's probably the case that we need to count the number of prime divisors that are here. Somehow we are to count something. Log max k. I don't think that works. wait, what? Okay, to the 16. Oh my god. By the way, I still humbly redirect you to next stream. This is just the last couple of problems, so most of the people aren't probably going to be interested in this. I'm just here to finish this off. So, supposing we binary search, now we need to count the number of pairs where the product is. Seriously, the viewer rate is going up now. Look at this, now it's higher. Actually, it was fluctuating a ton. Did it capture that point of 4? I remember. What's like the lowest point? Huh, it never recorded that. I guess 4 viewers never happened. Sure. Alright. How do we count this? So we're going to binary search on the number itself. What could the worst of k be? Sleeping somewhere in your mind? Yeah, it is, I know. Problem is my mind is sleeping. I don't know how to wake it up. Inclusion, exclusion? How? I remember not doing that, but maybe? I guess you could iterate over, if you choose the set of things that are inside it. I remember doing something else though. I forgot exactly what it was, but I remember it was something else. Well, wait, how do you do inclusion? How do you guarantee that the multiples you take are also in that prime set? I'm not sure how that would work. Maybe you can count the numbers that don't do that. I swear it was something to do with meet in the middle. I just forgot what it was. There's some solution that doesn't work if it's n equals 16, but maybe it does work for n equals smaller or something. Wait up. This could be it. Log 60 to the 8th. That's not the best, but log 10 to the 18th over log 3. Alright, so if we do like log 5, 25 to the 8th, it's not the worst. Alright, so we're doing 2 to the 6th. How bad does it get if you try and generate it explicitly? Wait, it should be 10 to the 18th to the 8th. I think it's still bad though. That's the problem. It's still bad to generate. It is still bad. But like, is it bad? I also remember it being super close. I remember a lot of things. Oh yeah, that's true. Yeah, the number of numbers you get is like a lot less. I'm pretty sure that's what I did. That's the thing. I'm pretty sure that's what I did. I'm pretty sure I just straight up generated half the sets at the same time and just... Okay, wait. Let's find like the absolute upper bound. So I'm going to use every other prime because we can like we can alternate like when we do that, so that it's like not all the smalls at once. So log 5, log 11, log 13, no, 17. Wait, what have I done? To the 8th. I want to see like the absolute upper bound. 19, 23, 29, 31, 37, 41, 47. How many primes is that? Okay, that's horrible. But we have 3.5 seconds. And, okay, let's see. Can we do the trick where we don't need to sort? Alright, we know the worst case already. We know the worst case is 16, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43. How many primes are there? 47. 53? I think that's right. There, I got 43. Yeah, 53. Okay, we got it. So, alright, so first of all, if n is equal to 1, then just do, actually, no, it doesn't matter. We only do that. Yeah, I'm pretty sure this is straight up what you do. You just generate both, and then you just combine them. It's just straight meet in the middle. We can do merge sort. We can do merge sort. Kind of. It's kind of weird how that works. It is kind of worse than sorting, I'm pretty sure, to do merge sort. Because we're merging like a bunch of different lists, and that's not great. Whatever. I'll just do it naively. We'll see. So. DFS is dumb. So let's do like the other way, which is probably dumber. Z. I'm out of variables. 1. Let's do it the other way. I can do it this way, right? Yeah, it should be fine. K times Y. I don't trust precision. Just make sure that's right. I don't trust precision, so I'm gonna type out this whole dumb number. K times equals Y. Wait, hang on. This doesn't make sense. Hang on. No, this comparison doesn't make sense. I'm gonna make this int 128. Well, if we multiply, then it's like a problem. And I never trust the divide formula. Like if you do k is less than 118 over whatever. I don't know why, but it seems like it should be wrong at some point because it's like flooring, isn't it? I feel like I've gone over it in my head a bunch of times. I still don't trust it. I'll do this. Like, because if you multiply, then it could go over, and then you can't do the comparison. Like, if you have 118 minus 1 times 91 or 97, I think that's prime. I'm gonna check that now. Yes. Okay. My intuition about primes has not failed me. MV push back. Is it fine to do this many pushbacks? I feel like it's a problem, but we'll see. The problem is going to be the sorting anyway, I guess. K times Z. V is equal to MV, turn V. Do I need to... My variable names are great, huh? So, what do we need to do exactly? We binary search here, and then we ask, we can do 2 pointers. 3 equals 118 equals 7. Wow. Got it. So, No, that's dumb. Oh, wait, no, it's fine. While point plus 1 is less than yy on size, and yy point plus 1. This is fine. This will overfill it too, won't it? I guess I can do the floor thing here. So I want yy point plus 1 times z is less than or equal to m. So this should be less than or equal to m over z. I guess it's fine because it's like, if it's that, it like works anyway. I don't know. Plus point. Count plus equals point. If count is less than or equal to k. Then count is less than k. Then go higher. Sorry, is equal to m. CL. Let's see. Awesome. That's not right. Okay, so let's figure out y. Yeah, those are some big numbers. Why are you negative? What? Oh, that's why. Okay, I'm just gonna keep it as int 128. If k top z is less than or equal to. This is dumb. I don't care. I don't think this is the bottleneck anyway. It's still 162. I still have negative numbers? No. Wait, why did the negatives not change anything? 1, 2, 4, 5, 8. So this is 2 and 5, the other one is 3. So, yeah. Debugging, love it. Kth smallest integer. What have I done? This should be point plus 1. That should do it. Nope. What's up with this? So why? Yeah, sure. I don't think it, I mean, it doesn't make a difference though. I mean, the problem is 27 is evaluating to 6. Also, I'm gonna forget inf if I do that. Yeah, this is just evaluating the tiny. Why is it a thing? Because this is supposed to be in reverse order. That's me being dumb. Also, I don't... Oh, I'm using the wrong vector. Okay. Yep, I'm smart. Now this is absurd. Why is that a thing? Well, it should be start off as -1. There we go. Come on. $93. Let's test the hard part, huh? That's not a good sign. That is very much not a good sign. Is it the division? 19. Oh wait. That could be it. Hang on. Could be because I didn't hit enter. Six, 7, 8, 9, 10. What have I? Okay. This is fun. This is a fun problem. I forgot how I solved this. Forgot how I resolved this. I didn't give K. That's why. That's why. Okay. We're good. I just didn't give the full input. Yeah, I just realized. Yeah, nice. Okay, wait, that doesn't seem right. There's no way it's that fast. Cannot be that fast. It's that fast? What? Dude, I remember my submission was like multiple seconds. This was close. What did I... This has to be like wrong then. Because it can't be that fast. Gotta be wrong, right? I don't believe this. I guess I believe it. Okay. Wait, what was the case that took so long then? If it wasn't that. Oh, it was bigger K. Okay, sure. If I run that on my own computer, is it like slower? Why is this so much slower? Is this just like code? Is this code forces being slower? Maybe my computer is just like super fast and I didn't even realize. Sweet. It's kind of a problem actually, but whatever. Okay, yeah. So that's that. Give K as input. I think we're good. We have one problem left. Kind of can't remake the observations for this, which is sort of sad, but yeah. Alright, we're one off. So, this is the final problem. You have a blackboard. You have an odd number x. Your goal is to write the number 1. On this blackboard, you can take two numbers. On this blackboard, you can take two numbers, x. So you have a number x. You can take two numbers, and you can write their XOR. And once you've written down this XOR, now you can use it in future operations. You can write their sum, and now that you've written this sum, you can use this sum in future operations. You want to get 1. That is how this problem works. Alright, so my solution was almost identical to the editorial except for the last part. So the way the solution works is the first thing to just try to do is to like gain as much power as you can with the operations that you have. And so the first thing you can realize that you can do is given x, get k times x. And the way you can do this is, if you recall, I went over binary exponentiation in the slide, the lecture, and words. Yeah, my brain is here right now. You can get given x, you can get k times x. And so with binary exponentiation, you can do x to the k in log time. And we'll do the same thing here. We have addition. In here, we have multiplication. We want to turn it into exponentiation. Here we have addition. We want to turn it into multiplication. So we can do a similar sort of thing. We can do binary addition, kind of. So we generate x, we generate 2x, we generate 4x, we generate 8x, we generate 16x, etc. And all of this is this is 8x plus 8x, of course. And then we convert k to binary and we take the ones that we want. You do have to solve problems to excel. That is true. I think the general consensus is that we agree with him on that. So we do all this. Yeah, that's reasonable. Right, so we convert k to binary, for example, if k equals 21, then we get 1, 0, 1, 0, 1, and so we take x plus 4x plus 16x. And there we go. We have used that. This problem is nice in that it doesn't make you find the indices of the numbers that you generated. You can just use the numbers and you'll be fine. It's not like that big a deal because you can do it anyway. It's just nice that they do that for you. So you can take x, you can take 4x, you can take 6. I didn't change the. Oh, I did not change the problem. Good point. How are these numbers different? I don't get that. What the hell? How are these numbers different? And like, this playbacks count is higher than the count I get like of views. I don't understand any of it. Alright, should be good. We have one thing left. Oh yeah, the bound of the numbers you can write is 5 times 10 to the 18th, but that's like fine. And you get at most 100,000 operations. Ow. Ah, that's a good time for my jaw to hurt, huh? So that is one thing we can do. Given x, get k times x. Now, recall that I have mentioned a thing before called Béziers theorem, which says for a given AB, ax plus by equals 1 has a solution. Or it's not Béziers theorem, it's like Béziers identity or something. I think I've sort of mixed that up the whole time. Whatever. Béziers theorem is probably something else, I think. But Béziers identity, I guess, is ax plus by equals 1 has a solution, and it can be found in log n. I remember during the contest I brute forced this in like O of x because I didn't actually understand extended GCD, and I still don't, but it should be fine now. So given coprime A and B, ax plus by equals 1 has a solution. And therefore, okay, or yeah, step 3. If we have even x, then x XOR x plus 1 is equal to 1. The reason is because like x is like some number of bits and a 0. And x plus 1 is the same bits and a 1. So XORing those two, all of these bits will cancel each other out, and we just get the 0 XOR the 1, which is the 1. Combining 2 and 3, if we get any two coprime numbers, then we're done. Because we can solve this equation, we can get k times x for both of these numbers, and then we're done. Because we can use these two coprime numbers to generate an even x, and then we get x XOR x plus 1. Actually, I forgot. I'm trying to remember how exactly we do that. We are looking for Ooh, we need the 2 consecutive numbers. I kind of forgot, how do we get 2 consecutive numbers? There might be a step 4 that I'm missing here. To get 2 consecutive numbers, we just need okay, yeah. To get 2 consecutive numbers, take right, we can find a number that's equal to 1 mod y. It's congruent to 1 mod y. So z mod y is equal to 1. And then we can take z minus 1. All right, how exactly do we I think brute force is probably easiest here, honestly. Because all these numbers are up to 10 to the 6th or so, I think. Actually, I'm kind of considering this now. How exactly did I do this? I remember I did it, I just forgot how exactly I did it. It's finding a number z that's 1 mod y, except it's also like... Like we need them to be, we need the smaller one to be even, otherwise it doesn't exactly work. And actually, okay. Okay, so the steps don't directly follow, but we can do the construction in such a way that b is even. And therefore, or y, sorry, this should be mod b. And then if b is even, then if we have z equals 1 mod b, then we're fine. Okay, yeah. I forgot how I did this. So we can make b even. So the last part is how to find 2 coprime numbers. And it turns out that is simple. Let us find a way to get a power of 2. And then we can take any other number and it'll be coprime with that power of 2. Just because, like 2, or 10, if we take any odd number, it'll be coprime with the power of 2. So how do we get a power of 2? That is a good question. Actually, can we get a power of 2? Kind of wondering that now. Yes, okay, right. So this is sort of a construction from the editorial. Let our number, let x, say x is like some like number and it begins in 1 and ends in 1 because we know x is odd. So let's shift x. Actually, wait, let's move this over here. let's shift x in such a way that we get that this one that the ending one of this x, of the shifted x, aligns with the beginning one of the other x. XORing these two, we get everything is the same but these bits. Now, adding these two together, we get this, except we get these two ones. So it's plus 2 times whatever this was, whatever the value of this bit was. And it's 2, and this value of a bit is a power of 2. So it's 2 times a power of 2, meaning it's still a power of 2. So we can get our power of 2 by taking x plus shifted x minus x XOR shifted x. And that gives us a power of 2, and that power of 2 is co-prime with x, and therefore we can be done. Should be good. So, yeah, now let's implement that. That is the final problem. Now I can get lunch or something. I don't know. So read into x. Let's do some stuff first. So first, a. Ops. Push back. You know about string streams? String streams will let you like format strings however you want. Like you can print to a string stream and it'll like print to that string instead of printing to like cout or something. So it behaves the same way. And then you can get like the stir. Pushback, os.stir. So that's kind of a cool thing. So we do x XOR x to get 0. So we're going to do binary multiplication as well, which looks familiar to binary exponentiation. So v is equal to k, no, x, while k, if k is odd, we do an operation, cur is equal to x, right? Cur is equal to x, then we like multiply it by 2. Ops dot what? No. Wait, we're starting with x. We're starting with x, we're taking 2x, we're taking 3x, etc. Yeah. Okay, so cur plus v plus equals cur. Divide k by 2 op cur plus cur times equals 2. So that's how we do this. You're generating x times k iteratively. Let's test that. Do I have multi-test here? No. string. Um, 1 of 5. There we go. Seems legit. Okay, so might be better to do it this way. Yeah. Anyway, it doesn't matter. So that's good. We did binary multiplication. So let's see. We've done this part. Now we find the MSB of x. 63 minus built-in. I remember I did this. I did another MSB at the beginning of the stream, right? That felt so long ago. It's kind of weird. In the beginning of the stream, like, felt like days ago. I swear to God. This is so weird. So bin mul x times 2 to the MSB. Let's do bin mul big. Alright. Should be x, comma. Yeah, so do this multiplication. Now we XOR those two. Wait, how do I subtract? Wait, I kind of messed this up. Wait, okay. What did I do? No, this doesn't make sense. How would I subtract? If I could subtract, that would mess everything up. Do I make it look easy? I don't feel like this doesn't feel like it's easy. My sanity is definitely going away. I mean, I just realized that like this whole basis of stuff is wrong. Yes, I'm still going. I'm always still going. It's only been 5 hours. You know, my other streams have gone up to 6 sometimes. Yeah, I'm kind of confused on what I've done now. Like, what have I done? Like, genuinely, what have I done? What have I done? I can't subtract. What did I think I was gonna do? Oh wait, no. Okay, never mind. Okay, I was kind of confused. I don't think we can we make B even? I don't think we can. Can we? Well, wait, okay. I kind of screwed this up. I don't know what I was thinking with subtraction, but we can still do this. Specifically... How do you send it? Does Google have that by default, that emoji? Interesting. Or is that from like another stream? YouTube something. Looks like a hamburger from far away. It's funny. Okay, well actually what this is this number is x. What? This number is x. This number in particular is x times, it's this plus this. So 1 plus 2 to the MSB minus whatever this is, 2 to the MSB plus 1. And that is co-prime with x because like GCD of like stuff minus stuff is still the same thing. I've eaten breakfast. Right, so this is still co-prime with x. Because this is a multiple of x, this is not a multiple of x. Therefore, this can't be coprime. No, this has to be coprime. Cannot be a divisor, cannot be a multiple of x. So, yeah, then we can add x one more time to make it even. There we go. Now we have even b. So we XOR this. And then we XOR, all right. Is that the YouTube section? Why did they have that? Who added that? Why am I putting a space between every line? Who knows? Who knows, man? Okay, so we get like, we have 2 coprime stuff. So let's find the solution to ax plus by equals 1. We know b is even. So we know if we subtract, wait, this doesn't, does this make sense? Ax mod y is equal to 1, right? So if we subtract 1, we get ax plus by equals 0. Ax mod y is equal to 0. Therefore, ax is even. Therefore, that number is even. Yeah, this should be fine. Okay, let's just copy extended GCD now. And then we'll be done. Reference CP algo. Yeah, geeks for geeks has the same implementation. So int GCD, what do I need to do? So I know these two are coprime. So we get x, v, no, I'm already using v. Big is equal to so we're GCDing x big. We're not using the value for, what are we using? What are we using? We are using it, I think. Are we using it? Yeah, I played that game. V, W. I'm using random letters at this point. V is equal to V plus W mod W. W is equal to W mod. I'm just making sure they're positive. Plus. What am I doing with this exactly? Let's make sure it's bigger, right? V mod V. Yeah, I have one more problem left to do. No, I'm not going to do type tracing. This is it. We're done after this. I need to make sure it's bigger. Alright. How exactly did I do that? So to make it bigger, I would want how do I do this? I'm losing my mind. Just like do like v plus equals big, right? Sure. So op x bin mol xv bin mol big W should be this, right? Yeah, because if we subtract multiples of x, then it's fine. Op x times v, big times w. And we need the sum of these over 2. Over big. And that should work. This should be that minus 1. Then plus x over. Okay, let's see. 5. Awesome. Well, it works. It's just negative. Sweet. That's why. Why are they ints in the first place? Nope. So why did I make them ints? 5. Still. Odd. Exactly. Where exactly is this overflowing? Stop pasting that in. Let's see, where do I print that? 110. What am I printing? Oh wait, it's like at the very beginning. What am I printing? Oh, upset size, right, okay. So big is not big, in fact. Big is tiny. What the hell is MSB? MSB is, oh, it's pop. Why did I do pop count? Holy crap. Okay, that makes sense. That is awesome to do that. Pop count, love it. Great. I'm gonna trust that it works. I don't care if it does or doesn't. If we get a wrong answer, that's fine. I'm gonna trust it though. Test 9. There we go. That is it. All right, that settles it, huh? That was a pain. That was a long... This actually wasn't that bad, this problem. Alright, that's the stream. I think we're done here, right? Got nothing left to do. Go watch Next Thing if it's still going. It is still going. Probably tune in myself. I'm not gonna... This is like the... Actually, no. I've heard it's against US to raid a stream from YouTube on Twitch. So I am not raiding him, but I'm saying you should watch him. There we go. So, yeah, like I said, I'm thinking about a video on, like, focus, which I have mentioned before. Because people ask me, like, how I balance school and stuff like that. So I'm thinking about a video that shows a trick that you can use to focus and stuff like that. You should tell me what you think about that later. Yeah, timestamps. Yeah, I'm gonna do that for the last stream too, like, hopefully today, I don't know, sometime. I guess we're done. Yeah, that was cool. Please, Tetch. Tetch what? Okay. Twitch? No. We get all the viewers like at the very end of the stream. How cool is that? Here's what's left of my water. Okay, I'm gonna say bye now. See you guys soon. Probably in the Div 3 tomorrow, actually, because like that's the thing that happens. Div 3 tomorrow. Okay, bye. I'll do the timestamps like probably not right after, but soon, like sometime today. Okay, like actual bye.